Good morning, everyone. The participants are still joining. We'll just wait for 2 more minutes and we'll just begin that. All right, we'll start now. Thank you so much, everyone, for joining us today. This is day 2 of the TOT program, and today our trainer will be Dr. Sivarasu, who will be covering concepts on energy efficiency applications within the industrial setup. Some basic instructions before we start the program. First and foremost, please keep your microphones and cameras off. In case there is a question that you need to ask the trainer, you can post it in the chat box, and the trainer will take it up when the training is on. Also, in case there's any other pressing question that comes up during the training that you want to ask directly to the trainer, you may switch on your mic when the trainer indicates so. We'll be sharing a feedback form at the end of the day, so please make sure you fill in the feedback form, and that will be a confirmation of your participation in day 2. I hope you've all filled the feedback forms for day 1. Those who've not been able to fill, we'll be resharing the link once again somewhere in the middle of the day, and then you can fill in your feedback. We'll be following a similar process for day 3 also. And for certifications, please keep in mind that you fill in the feedback forms, because that will be a verification of your attendance of the program. So if you fill feedback forms for all days, day 1, day 2, day 3, then we'll give you a complete certificate for attending this program next week. However, if there are any missing feedback forms that you've not been able to fill in, please make sure you fill them. We'll be sharing all links again at the end of each day. Any missing feedback form will lead to us giving you only a partial certification for this program. So with that, I have completed most of the basic instructions. Any questions, you also have to be organizers of the training, that is myself and my colleague Sneha. You can please post it in the chat box or the WhatsApp group, and we'll address your queries there. Now I just pass it on to Dr. Sivarasu to begin the program. Over to you, Dr. Sivarasu.
Madam, is it clear, madam? Can you able to?
Yes, I can hear you. Yes.
Can you share the screen, madam?
Yes.
Have you given the permission to share the screen?
Yes, I've just done that. Please check and let me know if you can share your screen.
Visible?
Yeah, I think it will be visible. Yeah, visible now.
Now it is full screen, madam. Is
Yes,
it okay?
it's visible.
Okay.
Dr. Sivarasu, before you begin, I just request you if you can give a brief introduction about yourself.
Oh, okay. Okay. I think I shared the one-page slide to you. Is it available with you? Or?
Just a second, we'll look for it. Can I request you to begin while we do that?
Okay. I stopped the sharing, madam. Is it available with you?
Dr. Sivarasu, it might take me a little few minutes to look for it. May I request you to begin? I'll project.
No problem, madam. It is available with me. I can project.
Okay, okay. All right.
Thank you. Now visible, madam?
Yes.
Okay.
Yes, sir.
Thank you. Thank you. Madam, kindly follow any questions in the chat box because I'm out of chat box now. So therefore, I can't able to see whether any questions are coming in the chat box.
Sure, Dr. Sivarasu, we'll let you know as the questions come.
Questions comes. Similarly, if any participants want to talk with me regarding the questions, that also please indicate me so that I can stop at the appropriate time and answer.
Definitely. So what we can do, Dr. Sivarasu, is you can continue with the training, and right before we are about to take a short break, we can just open up for questions 5 minutes before that. Is that fine?
Okay, madam. Okay.
Okay.
Good morning to one and all present here. I know it is a pandemic time. Still, we are not open all. Of course, today we got an information that all the colleges should be open by 1st of February. The COVID cases are lesser as per the government instruction. But we are conducting this program on online mode of teaching learning. So that we are here, approximately 70 participants are here now. I can share you the basic information about the energy efficiency, particularly for electrical today and thermal system for tomorrow. Yes, small introduction. My name is Dr. Want to have a talk? Hello. Hello. I kindly request please mute your mic. Participants. Yeah, thank you. My name is Dr. Sivarasu. I completed my diploma BE in electrical engineering, Master of Engineering in Power Quality, Power Electronics and Drives, and completed my PhD in Renewable Energy System and Power Quality. I'm a certified energy auditor. My certification number is EA 27299. I'm also a lead auditor for ISO 14001 Environmental Management System. Accredited profession for Indian Green Building Council, certified profession by GRIHA, also a certified profession by CII, in solid waste management, certification professional on carbon footprint audit and implementer as per the ISO 14064. Nearly 100 energy audits we completed. Not only energy audit, environmental audit, green audits we completed for the past 5 years. Including 5 major airports: Coimbatore Airport, Madurai Airport, Pondicherry, Thoothukudi, Vijayawada, and nearly 20 to 25 tea industries in Nilgiri districts, and more than 40 education institutions, including Periyar University, Bharathasan University, Amartha University, KSR group of institutions, PhD group of institutions, and so on. Also, we conducted energy auditing for 4 railway colonies in Coimbatore, Salem, Karur, Pottanur, and Erode. I'm a guest faculty for Janssen School of Business, Coimbatore, Dr. J.J. Fisher University, Nagapattinam, and also Karpagam College of Engineering, Coimbatore. I am also a master trainer for Industrial Casting Coimbatore, Roots Casting Coimbatore, Lucas TVS Chennai, and holding an additional responsibility of coordinator for the MSME cluster. It is taken by it's an initiative of SPANC CSR activity, and currently I'm a managing partner of Ramkalam Center for Energy Consultancy and Training. A small introduction about this one. Kindly bear with me. I have to change my slide from this point to presentation so that it may take 1 or 2 minutes. Kindly bear with me. And similarly, I will switch over from one slide to another slide because some of the points which I want to elaborate to you from one slide to another slide. So therefore, there may be a small change in time is required for me. So the participants, please kindly bear with me. Now this 3-day TOT program mainly concentrating on giving an awareness to the faculty members of engineering and polytechnic colleges, such that 3 important verticals. One is solar energy system, which include both photovoltaic as well as thermal. Energy efficiency, again, it has 2 different verticals. One is electrical and another one is thermal. So we have a 3: solar, electrical, energy efficiency in electrical, energy efficiency in thermal, to be given to the students through the faculty members. So therefore, it was very sincerely, very honestly, very carefully coined by the sustainable communities, Institute of Sustainable Communities. That's why we are here to teach you the basic information about the energy efficiency and solar systems. I think yesterday, Dr. Vimal team gave an elaborate idea about the solar system. He was a veteran in the solar field, especially solar photovoltaic system. He installed so many installations, so rooftop solar thermal, process application for the solar photovoltaic system, process application for the solar thermal systems, and so on. So I think you learned a lot of things yesterday, and I hope today I also give some information to you, and that will be very useful for your personal career, as well as will be useful for your teaching to your students. Now let me come to the point of the basic of energy management. Before going to talk about the technical topic, I would like to thank the management of ISC. Especially, I have to thank the management of ISC, Amit ji, Ananya madam, Sneha madam, Dr. Vimal, and Mr. Khan, who are organizing this event in a very grand successful manner. And I also thank the participant for, even though it is a pandemic time, even though you have an online schedule for taking the classes, conducting the labs, your assessment of academic activity. So you are spending here for the 3 days, and moreover around 6 hours in a day. So I must appreciate your intention to get some information about the solar as well as the energy system. Now, basics of energy management, which includes a very simple idea: what is energy? As most of the people will know that. I'm just talking about this to be taught to the students' perspective. I'm just talking about this in the terms of a teacher to teach this information to the students. Of course, this is going to be somewhat basic, which is known for the faculty, some of the faculty members. So therefore, kindly forgive me, though we have to address in this manner only. But I will give you some case studies, example case studies, industrial case studies, some implemented projects, results of the implemented project with my experience when we did energy auditing. So the basic energy to be taught to the students, such that what is energy and what is the definition for the energy. Most probably we have 2 types of energy. One is an electrical and one is a mechanical. Of course, we have chemical energy and all those things are available. But as far as energy efficiency is concerned, energy auditing is concerned, energy management is concerned, we are mainly focusing on the thermal energy system or mechanical energy system, and another one is an electrical energy system. Now, some of the examples are shown here. Some I will use my pointer. So here you can see the boiler. Boiler is a mechanical instrument. Of course, we have some auxiliary instrument which are also using electrical. The boiler is mainly used to generate the steam from the ordinary water. So either the fuel of the boiler may be a wood or LPG or rice husk or even coal, but the output is going to be steam. So you need to heat the water up to a maximum of more than 100 degrees. So automatically the liquid state will come to a gaseous state, so that the output will come in the from the boiler. So that can be used as used for process application. Now similarly, you have a motor. A motor input is going to be an electrical, output is a mechanical. So any device, the input is required, output is required. So sometimes input and output are same domain, sometimes input and output are different domain. I will give you an example. For example, of a motor, the input is mechanical, output is electrical. Both are different. Both having different domain. One is an electrical input, another one is a mechanical input. Similarly, if you take the gearbox, input is a mechanical, output is also mechanical. If you take the generator, the input is mechanical, output is electrical. So when you see the end device, sorry, what you are going to use for your process application, the input and output sometimes maybe in the same unit or same domain, or sometimes it in the different domain. I will give you one more example, a transformer, which is well known for the faculty members in the electrical department, as well as all the people. The input for the transformer is electrical, output is also electrical. So likewise, sometimes it may be similar, sometimes it may be different. But the only thing is in what type of input you are doing, what type of output you are taking, and what is the measurable unit for each and every equipment or system to be considered. Similarly, for the compressor, you are giving electrical input and you are getting a compressor as an output. Okay. Now, basically, the energy was divided into two different sources. Of course, we have 5 different classifications, I will show you later. Based on the source, we have a primary energy, and one is a secondary energy, and based on the natural availability, it is a renewable and non-renewable. Of course, most of the people will know that primary energy is we can take it from the earth or from the nature, and directly you can use it, for example, coal, oil, like that. Secondary energy it's a derived. You can't able to directly use it. Rather, you need to some conversion. You need some process to convert that into an usable format. For example, steam, electricity. Electricity is a secondary, because you are taking the electricity from coal or water or thermal or nuclear, whatever it may be. So it's a converted one. So earlier form of the energy is not the same. So therefore, it's a secondary. Renewable, actually, the name itself indicating that it is inexhaustible. It is always available in the earth. Rather, non-renewable, it is a limited one, conventional. It's almost a limited one, time period, time bound. So that's called as a renewable. So this will give you a clear-cut idea about the major primary and secondary energy sources. I will give you a more appropriate slide after this. And we have a commercial energy, non-commercial energy, and we have a renewable energy, non-renewable energy, and we have an electrical energy and thermal energy. I will show you the other slides, which will be an eye-opening for you to give a more important forms of this type of energy. Sorry. I think it is visible. Am I correct? I think it is visible.
Yes.
Okay, thank you. Now you can classify the type of energy in 5 different domains, 5 different regions, and from that it is again divided into so many classifications. Basically, I am classifying the energy in source-based energy, where we have a primary and secondary. Again, in primary we have a renewable, and this may be the right classification, which will accommodate all the type of energy, all the forms of energy also. Okay. Now the primary, again, we have a renewable as well as non. Again, secondary we have a different. Again, the second classification is use-based. We have a commercial energy, another one is a non-commercial energy. And third one is going to be technology-based. It's conventional and non-conventional. Conventional means it is available. As of now, it is available. Non-conventional means it is not available for regular use of application. It is in the R&D stage. One point you must always keep remember as a faculty member, that the non-conventional energy now it will become in conventional in tomorrow. Tomorrow. And similarly, today conventional energy was a non-conventional in yesterday life. So that's the point I want always to keep remember in your mind. And second one, and fourth one is going to be emission based. We have two types of available. One is a local pollution, another one is a global pollution. I will come to the point later. And the last one is a storage based, whether the energy can be storable or non-storable. Okay. Now the detailed classification of the source based energy, we have a primary as well as secondary. Again, which already discussed, it is directly extracted, captured from the flow or which is available in the stock for the natural resources, and do not have any transformation. You need not have any conversion. You need not heat up. You need not purify. You need not do any process. You can directly take the energy from the earth, from the nature, from the storage, and directly you can use it. The example is going to be coal, oil, and even solar also. Of course, solar is going to be comes into the picture of the renewable, because it is inexhaustible in nature. It will be always available throughout the entire 365 days. It will be always available for all the region, almost all the region. Non-renewable, it is infinite. It's a finite stock. It will be completely exhausted at one particular time. Secondary energy, we need to have some process to purify it, or to heat up the oil, or heat up the system, and you can take the extract, and that is going to be a secondary. The example is going to be electricity generated from the coal or petroleum product. So those are all the secondary energy. Now, commercial, the name itself indicating that if you sold the energy in the market, or if you have an energy that can be sold in the market, or you can able to sold in the market, those energies are called as a commercial. For example, oil is going to be an almost commercial. You can buy it from the market, not from the local market. It's going to be a global market, and of course we have a national level market also available. And similarly, the electricity also comes into the picture for the commercial energy. You can buy electricity from the commercial market like IEX, TDX, so like that. Whereas the non-commercial energy, you can't be able to sold in the market. For example, wood, which is collected from the forest. Of course, wood can be collected from the forest, or wood can be taken from your own trees, which normally used for your own applications. We are not selling this wood for greater application. Of course, for boiler, we are using for this type of wood. Of course, this is going to be somewhat commercial as well as non-commercial terms. If you use it for your own application, it is a non-commercial. If it is sold to the other party through the market or through a platform, so that's called as a non-commercial energy. For technology base, I told you conventional, which is available in the world, which is very familiar to operate, familiar to extract the energy. So those are called as conventional. Whereas non-conventional, which is in the earlier stage, or novel, or new, or in the R&D stage, that's called as non-conventional energy. For example, ocean energy will be non-conventional. Pollution, based on your pollution, while doing the activity, or while you burn the energy, or while you use the energy, definitely some amount of pollution comes out. When the pollution is going to be in the vicinity of the source where you are emitted, so that's called as local pollution. So that will be only affecting your local pollution. That means, for example, the sulfur dioxide, particulate matters. So those will be only affecting your surrounding, not beyond the 5 kilometer radius, or the 10 kilometer radius, or even 100 kilometer radius. Whereas if you use some amount of energy, some type of energy, some form of energy, that will release a huge amount of pollutant, which will affect the entire globe, entire atmosphere. For example, carbon dioxide, greenhouse gases. So those type of energies are called as a global pollutant type of energies. Okay, I don't want to spend those type of the energy system, which already you know that. Okay, so that's why we are mainly concerning about the global warming, and similarly the carbon dioxide, CO2 emission, and all those things. Okay, so that's why I'm writing carbon dioxide, not a DI. So storable, in the form of storable, you can easily store in the form of in the physical medium, that's called as an energy commodity. For example, you can store the oil, you can store the coal, so it's storable. Whereas non-storable, physical format, you can't able to store, that's called as non-storable. I'm representing it in terms of electricity. Why? Because we have a battery is available to store the electricity, but it is not for the longer time. And similarly, for the huge amount of electricity, cannot be stored in a battery. So electricity can be either, you can take it as a storable or non-storable. That depends on the volume of energy, volume of electricity you are going to store, and similarly how long you are going to store this energy. So that's why it comes exactly in the non-storable, but for the small amount of quantity it is storable. Okay. Again, back to our main slide. We have an electrical energy concern. Electrical energy, which can be first dealt with that elaborate way. I know if people are from mechanical background, don't bother. It is very simple and very easy to understand. And similarly, it's only a basics, not an bombastic hybrid machines are available. Okay. Now we have a work and power, energy and power. Power can be represented by wattage or kilowattage or megawattage, which can be given by a simple equation of power equal to work done by the system or the network divided by the time. How much amount of time it takes. And similarly, work is going to be given by joules. Energy can be represented in terms of kilowatt hour, joules, or kilocalorie. You can convert from one quantity to another quantity. It's very simple. I will show you the conversion factor also. So you have to teach to your students such that it is very easy to understand the mechanical concept for the electrical students. It is very easy to understand the electrical concept for the mechanical students. Okay, now work equal to force into the how much amount of distance you are going to. We have two type of energy. One is a direct current, electrical. One is a direct current, and one is alternating current. Most probably we are using for regular applications. We are using alternating current, which is changing the positive and negative with the help of a cyclic arrangement. So that can be represented by a symbolic representation. And 4 or 5 important variables are available in the electrical. One is current, one is voltage, and the third one is power, and fourth one is going to be energy, and fifth one is going to be resistance. Only these 5 is the basic parameters. Of course, we have other parameters are available that is not directly or most probably involved in the energy efficiency calculations. So that's why we are mainly restricted to current as well as the voltage, which is very similar to the mechanical engineering. I will tell you the voltage is equal to force, and current equal to flow. For example, it's a water or an air. The flow is directly proportional to current, and similarly, the voltage is directly proportional to the force. It's very simple, just analogous. You can analog the electrical parameter with the mechanical parameter, and mechanical parameter with the magnetic parameters, and magnetic parameters with again electrical parameters. It's very simple. We can easily connect. I will also connect the electrical parameter with the magnetic parameters. You know, the magnetic circuit will be available. We have two type of magnetic circuit. One is an electromagnetic circuit, and another one is a permanent magnetic circuit. Of course, 90% of our applications are electromagnetic circuit. When you give an electrical current, electrical supply to a coil which is having an iron or a magnetic medium, automatically a magnetic field is established. Right? Now the magnetic field will be also equivalent to your electrical. In magnetic field, you have a magnetomotive force, MMF. In electrical, it is going to be an EMF, electromotive force. In electrical, it is a current. In the magnetic field, it is going to be flux. Almost same. In electrical, it is a resistance. In the magnetic circuit, it's going to be reluctance. Just opposite. Just opposite to the flow of the current, flow of the flux, which is going to be reluctance. So any system, any parameter can be easily equated, analogous to one form to another form. If you know this point very correctly, then it is very easy to understand the concept of electrical engineering as well as mechanical engineering or energy efficiency, because energy efficiency, energy management, energy conservation, energy concept, energy auditing will always deal not only electrical, not only the mechanical. It is a combination of both mechanical as well as electrical. So that is why it is very simple to understand the concept. Okay. Now we have a resistance and frequency. I told you it's a flow when the flow of current will be opposite based on quantity, that's called as resistance, and frequency is going to be change in the alternating current at a periodic cycle, that's called as frequency. Now we have an electrical quantity. Electrical energy can be represented by the charge as well as the voltage potential, and these are all some of the factors which are related to the electrical energy. Okay. Now I will switch on to the other slide, which is going to be given, which will give you a more emphasis on the electrical case. Okay. Now this is very simple. Now this will also give you a clear idea about the understanding about the electrical. Now it is visible, right? Can someone please tell me whether it is visible or not?
Yes, sir. You are visible, yes, sir. That is visible, sir.
Thank you, sir. Thank you.
This is Dr. Aravind, sir. Thank you.
Yeah, thank you.
Sir, visible, sir.
Okay, thank you.
Sir, I am Krishnamurthy. It's visible, sir.
Yes, sir. Thank you, sir. Thank you. Now the basics of energy, especially electrical energy, it's very simple. We have only energy and power. So from that we can derive all the parameters. Energy represent the potential to do the work. The unit for the energy, not normally what we are to do, for what we are representing for electrical people, we are representing in terms of watt second, or more probably watt second, and sometimes we are representing in joules. Now power, which is already related with an electrical energy, it is the rate of doing work or rate at which the energy is being utilized or to be converted from one form to another form. Now, the only thing is the difference between the power and energy is the time. The name itself indicating it's a rate of doing work, or rate at which the energy is being used. I mean, at what faster or up to what time you're using this energy. So time comes into picture. So when you have an energy power, then definitely the time also will come into picture. So two parameters now will become three. Now the third parameter is time. So you can equate the power, energy, and time with a very simple phenomena, very simple phenomena. Power equal to energy divided by time. Now, what is energy? Energy equal to watt second divided by time. So that's your power. So power multiplied by time will be given a very simple example of an energy. You can, I think you can do some manipulation. If you know the power, if you know the energy, you can find the time. If you know the energy, if you know the time, you can find the power. And if you know the power and if you know the time, you can calculate the energy. So likewise, if two parameters are known, easily third parameter can be found out, right? Now coming to the point of the unit for the electrical energy is 1 watt second, which is exactly equal to 1 joules. It's very simple, very basic. Okay. Now 1 joule equal to 1 watt second. Okay. Now I am converting this to our electrical quantity, because electrical quantity is watt hour or kilowatt hour or megawatt hour or even more than that. So I'm converting watt second to watt hour. So what can I do? Watt is a single one. Am I correct? Now that can be converted into 1000. If I multiply with 1000, then wattage will become kilowatt. Am I correct? Kilo equal to 10,000 multiply by 1000. So if I multiply by 1000, 1 multiply by 1000, then this term will become 1 kilowatt. And similarly, 1 second will be multiplied by 3600 seconds, then that will become hour. So if you multiply 1000, that will become kilowatt, and if you multiply 3600, that will become per second, will become hour. So 1 multiplied by 1000 multiplied by 3600, which is exactly equal to 1 kilowatt hour, because you're converting wattage into kilowatt, second into hour. So 1 kilowatt hour equal to, you multiply all the things, 1 into 1000 into 3600, that will be exactly equal to 36 lakh joules. So it is very simple, 1 kilowatt hour, 1 unit of electricity equal to 36 joules. That's all. Okay, so this point always you must insist to the students that if you know the joules, if you know the kilowatt hour, if you know the kilocalorie, then automatically one form of energy can be converted to another form of energy, another unit of energy. So 36 lakh joules will be exactly equal to 3.6 into 10 power 6, or which is nothing but your megajoules. Correct? So 1 kilowatt hour equal to 3.6 megajoules. Right? And similarly, for the energy can be converted, or you can have one more unit called Newton meter, which is mainly used for rotating body like generator and motor, where 1 joule equal to 1 Newton meter. Very simple. Often you can represent the power equal to output power of the motor, or output power of the rotating machine will be equal to omega into T, where omega equal to speed, angular speed of the machine, angular speed of the particular rotating equipment, which is given by 2 pi n divided by 60, where n equal to speed of the rotating object or rotating parts. And torque is represented in terms of the Newton meter. So this is the basic idea about the electrical energy, right? Now in electrical energy, as I told you, we have a two type. One is an AC or one is an DC. Now I have a simple comparison about the DC circuit and AC circuit. What are the electrical parameters which are mainly involving in the DC as well as in the AC? Of course, AC we have some more additional parameters, but some common parameters. For example, voltage is common. Current is common. Unit is also common. Power is also common, but only thing is the way in which you calculate the power for the AC circuit is different from the DC circuit. Okay, for the DC circuit, the power equal to voltage into current, whereas the AC circuit for single phase application, you can multiply the voltage, multiply the current, multiply the cos phi, where cos phi is the power factor. I will tell you cos phi, importance of the cos phi and all those things in later slides. Okay, so directly you can multiply the voltage into current. DC is valid, it is viable, whereas multiplying voltage into current in the AC circuit is not valid, not viable. You can also include cos phi. Okay, so you can take the power factor also taken into account to calculate that power on a single phase circuit. Okay, now it is a 3 phase. It's very simple. Multiply by 3. That's all. 3 into VA into cos phi. That's all. It's very simple. Okay. Now in 3 phase we have a 2 circuit. What is a star connection, delta connection? I don't want to go there. Okay. So just multiply 3 into voltage into current into cos phi for individual measurement or for the total measurement. That's enough. Okay, so we have a separate discussions if they required to calculate for a star connection, delta connection. Of course, both are same. Now, in the case of DC circuit, it's a resistance, voltage divided by current. Whereas in the case of AC circuit, it's not a resistance. Now it is an impedance. Again, the unit is going to be the same. Impedance unit is going to be ohms, and resistance is also ohms. Now the impedance is represented by voltage divided by current I. Is correct, but now it is represented by the impedance, because in the resistance, in the impedance, not only the resistance, other components are also added. So that's why it's an impedance, not the name exactly the resistance. The another variable is frequency, that already we saw that it is keep on changing its direction. Now sometimes it's a positive, sometimes it could be negative, again positive and negative. So frequently it changes its direction. That's why it's called as a frequency. And Indian supply system have a frequency of 50 Hz, which is exactly equal to 1 divided by 50, which is equal to 20 milliseconds. For completing one cycle, it takes 20 milliseconds or 0.02 seconds. Now you may give me a simple example, or simple application of faculty members, students, initial learners about the to familiarize the units, the parameters, all the things. I have a simple example. Let us assume that we have a simple example of an electrical heater that consumes 1.8 megajoules when connecting to a 250 voltage supply for 30 minutes. Find the power rating of the heater and the current consumed by the heater. It's a very simple problem. Very simple problem. I have two different solutions. Both are having the same answer. Okay. Now I know that 1 kilowatt hour equal to 3.6 megajoule, correct? Now, if it is a 1 kilowatt hour is 3.6 megajoule means now it consumes only 3.6 megawatt is 1 kilowatt hour means now the present problem will have only 1.8 megawatt or megajoules, now which is exactly equal to 0.5. Am I correct? So 3.6 is going to be 1 means then 1.8 equal to exactly 5, exactly divided by 2. So it's a 0.5 kilowatt hour. So I know the power equal to energy divided by time. So energy is available. So it consumes 0.5 unit of electricity for 30 minutes of the duration. Okay, so now I'm converting in the top I'm having hour. Now in the bottom I'm having a minute, so therefore I have to convert from the hour. So 30 minutes equal to 0.5 hour or 0.5 hours. Half hour. Okay, so 0.5 divided by 0.5, which is exactly equal to hour will cancel 0.5 will become 1. So 1 is 1 kilowatt or 1000 wattage. So the power rating of the heater is exactly 1 kilowatt. So if you connect 250 voltage to 1 kilowatt of heater and it for 30 minutes it consumes 0.5 units. That's all. In other words, you can tell like this. Okay. Now, what is the current consumed? Again, it's very simple. If I know the power, then automatically voltage is given. Power divided by voltage. I equal to V by power equal to voltage into current, because it's easy. There is no mentioning about mentioning about the power factor and all those things. So therefore, let us take this is going to be an AC. So this is cute. Even though it is going to be an AC, the heater coil will always have a power factor of 1, cos phi equal to 1. So therefore, power factor is not given. So therefore, you can assume that it is going to be a DC circuit, or even though it's going to be an AC, automatically you can go for an cos phi equal to 1. Assuming that cos phi equal to 1, then voltage into current equal to power equal, so I equal to power divided by voltage. So automatically 1000 divided by 2, 4 ampere current will be flowing through the cable to the coil to heat up the water for 30 minutes to consume 1.8. Right? Then we have another solution. Again, you know that energy divided by time. Energy is available. Time is also available. You have to go there and you can calculate the things. Second example, I don't want to mention this. One minute. Please, 1 minute. Hello. Sir, our meeting will sir. Please. Sir. In similar fashion, you can give some simple examples for the students members to familiarize the voltage, current, power, energy different from kilowatt hour, joules, like that. Okay, so that will give you an idea. So these are all some of the examples. Now I come to the part of the power factor, which is the next stage. We will come to the power factor. Again, we will go to the main slide. Sorry. Okay. Now this is our main slide. How to calculate the energy for a given load applications. We have 2 different examples. One is an electrical heater. Just now we saw that. But the way in which you have to calculate the current, we have 40 wattage CFL. This is the CFL, compact fluorescent lamp. 10 number of equipment, such equipments are connected in the system, and operating hours is going to be 10 hours. So how much amount of energy is consumed? It's very simple. 40 wattage into 10 total number of equipment multiplied by the operating hour, which will give the total energy consumed. 40 lamps of 10 numbers operating for 10 hours will consume 4000 watt hour, which is exactly equal to 4 kilowatt hour. Okay, so if it is running for 300 days or per annum, which is exactly equal to 1,200 kilowatt hour. So for 1 year, all the lamps are 40 wattage operating for 10 hours will consume 1,200 kilowatt hour or units. The same fashion, if you have an electrical heater which has a capacity of 10 kilowatt hour, I think 10 kilowatt hour is a very huge quantity. I don't know how this value was given. Maybe around 2 kilowatt is going to be normally used for our residential application. Of course, 10 kilowatt is going to be industrial heaters. Okay, 10 kilowatt, we have only one equipment operating for 16 hours. So automatically 10 into multiplied by 1 into 16, which is equal to 160 kilowatt hour. So within 16 hours, it consumes 160 kilowatt hour. If you connect the equipment for 300 days, automatically it is 48,000 kilowatt hour is the annual consumption, right? Now, what is the energy efficiency point of view is very simple. How we are going to calculate the efficiency of the system? Okay. Now, the efficiency of the system or an equipment or a device is very simple. Now, efficiency, already you know that the people are from the engineering background, so therefore the formula for the efficiency is going to be very simple. Input. Okay. Sorry, voice is clear? Ananya madam, voice is clear?
It is breaking sometimes. Voice
Okay.
is breaking.
1 minute. I think. Now it's disabled, sir. Hello.
Sir, sometime only it is breaking, sir. Otherwise, it's okay, sir.
Okay. Then I will continue, sir. If anything completely lost, please kindly inform me. Huh?
Okay, sir. Okay, right.
Okay, thank you. Now, all the faculty members know that the efficiency can be calculated by output divided by input. It's a very simple formula. If you multiply by 1,000, then it's going to be a percentage efficiency. Now, let me come to the point of 3 different examples. One is a motor, another one is a pump, another one is a blower. Of course, all are having the electrical motor. Only thing is the application is different. Now, in electrical motor, the input energy is electrical, output is going to be mechanical. Okay, now I'm just only talking about the mechanical power output. So my mechanical power output can be calculated by some simple ways, or sometimes you can measure the electrical input power and do some experiment to calculate the mechanical output power, and you can find the efficiency. Now the efficiency is going to be somewhere around 75%, 95%. This depends on the type of motor, history of the motor, service life, how many times it is rewinded. So many parameters are available. Okay, now where it is connected, what type of load it is connected, whether the load is going to be constant load or variable load, whether it is going to be connected to the machine directly or through the belt or through the VFD. So many things are available. Okay, so I'm just talking about only the efficiency of the motor, not the other things. The efficiency is normally between 75 to 95%. Okay. Now for the efficiency of the pumping system, again we are giving electrical energy to the motor, and it will start giving the mechanical energy to the pump. And because of the mechanical energy, the water or the liquid, which is from one place to be pumped to the other place to the process application. Now the efficiency of the motor is going to be 85% to 90%, where the pump efficiency is going to be 60 to 85%. This is very nominally put up. But the overall efficiency, which is concerned about how much amount of water supplied, how much amount of electrical input, that's called as an overall efficiency. So that's called as a pump system efficiency. Okay, we are not talking about the individual pump, individual motor. If you talk about the motor, or if you talk about the pump, the efficiency can be calculated separately. Whereas if it's a system, because it's a cascade, motor output is given to the input for the pump. Okay, now this is a cascade. Two systems are cascaded. Two systems are working closely together. So therefore, if you calculate the cascaded efficiency, then the total efficiency will be lesser. It's very simple. Cascaded efficiency equal to 0.85 multiplied by 0.6 in case if it's a lower value. In case if it's a very higher value, 0.9 into 0.85. So multiplication of this value will give you a cascaded efficiency. Similar fashion, in a blower, we will take the air from the atmosphere and will be given the process, the centrifugal action or backward curving arrangement. Again, here also, the efficiency of the motor is going to be very higher, whereas the fan efficiency is going to be very, very lesser. Again, if you put together the total efficiency, again, further it is going to be very lower. So therefore, increasing the efficiency is a very important concern, because saving 1 unit of electricity at the input side will be saving 3 units of electricity at the generation side. This point will be universally accepted by all the engineers, whether it's going to be electrical, mechanical, whatever. Okay, and you know that generating the electricity is going to be somewhat different, very difficult, and we are not getting the electricity then and there itself. It is generated somewhere else, but we are using somewhere else. So we have a huge amount of difference between the distance between the generation point to the load point. Of course, when you generate the electricity and somewhere else and you placing it somewhere else through the electrical power system, transmitting electrical power, definitely there must be a losses. And you know, there's a website called Udai website, and you can go to the website, Udai website, and you can see what is the transmission distribution losses for each state. Every day they are updating. And you know which state is going to be a very lower value of AT&C losses, aggregated technical and commercial losses. It is very, very simple. It is somewhat unimaginable. And you know which state will have a higher T&D losses. I will pass on this information to the faculty members. You can type this information, which has a higher AT&C losses, which has a lower AT&C losses in the chat box. You can take your own time. I will review this information in the break itself. So therefore, you can use your chat box to give the answer. Okay. So that is why the transmission system is going to be, efficiency, energy conservation is going to be a very important point. Okay. Now coming to the point of electrical utilization, we need a tariff. Okay. Whereas for a mechanical system, it is not a tariff based. So we are getting the coal, we are getting the wood, we are getting the furnace oil, we are getting the rice husk, whatever may be, depends on the local factors. Where it is produced, what is the quantity, and similarly, what is the quality of the equipment. That will decide the price, and that will decide the energy content of the equipment. Whereas electricity is not like that. The energy content of the electricity where it is produced is almost equal. If you have an energy content of the electricity, 1 kilowatt hour equal to 860 kilocalorie, which is same for Tamil Nadu as well as for Jammu and Kashmir. If you generate the electricity 1 kilowatt hour here or somewhere else, both are having the same. One unit of electricity will be exactly equal to 860 kilocalorie in terms of mechanical quantity, which is exactly equal to 3.6 megajoules, which is going to be the same. Whereas if you buy 1 kg of wood or 1 kg of 1 ton of wood in Tamil Nadu, 1 ton of wood in Maharashtra, both are different. The price is different, quality is different, moisture content is different, and similarly the energy content is also different. So therefore, the mechanical quantity, mechanical energy systems, the quantities which are producing the mechanical energy, the market price, the selling price is completely different based on so many parameters, whereas the electrical parameters are almost same. Only thing is different tariff. Tariff is based on the state, different state. Of course, India is moving for one nation, one tariff. I don't know whether it come or not, but it will come. It may have it is now in the discussion. Okay. Now for the electrical system, we have a tariff system. So tariff means in what way, how much amount of money I have to spend for buying 1 unit of electricity. Okay, so again, that depends on different category. Like we have what type of consumer you are, whether you are bulk consumer or you are a HT consumer or you are an LT consumer, and based on the consumer activity, you have a different tariffs available. Okay, now I will show you. Just back onto the my slides. I will show you the tariff details of. I will give the tariff details in an elaborate manner so that it will be very useful for you. Right? Now I think it is visible. It's a different slide. Now it's visible. This is only applicable for the Tamil Nadu. I'm just talking about the Tamil Nadu. So if any other participant from other states, please kindly correlate this information to your state electricity billing system. Okay. In Tamil Nadu, we have two type of consumers. One is LT consumer, and one is HT consumers. We have only 2 types. Okay. For HT consumer, the billing system consumption, everything is going to be different. Whereas LT consumers, it's different. Okay. Now, the main important point is how I have to differentiate the LT consumer and the HT consumer. Who are all the LT consumer and who are all the HT consumer? This is based on the sanctioned demand. So, how much amount of load you are having in your industry or your commercial plot or whatever may be. So, based on your sanctioned demand, you are classified into LT consumer and similarly HT consumer. Right now, for LT consumer, the maximum sanctioned demand is in Tamil Nadu. It is 112 kilowatt or 150 HP. Okay, clear? It is 112 kilowatt or 150 HP. If your connected load or sanctioned demand for your industry is or your institution is within 112 kilowatt or 150 HP, you comes under the category of LT consumer. For LT consumer, transformer is a common. The transformer is you are getting the electrical supply from a common transformer where other consumers are also connected. Okay. Now for the HT consumer, if you have connected load of more than 63 kilowatt, you are entitled to go for an HT consumer. I'm just repeating again. If you have a connected load of 63 kilowatt, you are entitled to go for an HT consumer. Okay. Now LT is up to 112. But if you are at 63, you have two options. Either you can stay in LT or you can go for HT. That depends on you. Okay. So even though you have a 70 kilowatt, 80 kilowatt, 90 kilowatt, 100 kilowatt, you may still go for a LT supply or HT supply. That depends on you. But when you go for HT supply, transformer is within your campus. You are the responsible person to handle the transformer. You have a separate transformer for you. The EB will give only the supply. But you have a proper transformer to step down the voltage, and you have a proper transformer yard, and electrical powerhouse for handling the HT supply system. And you need a C license holder or at least C license certified person to be available for certifying the property of your HT supply. Okay, so that's a very important point for the HT consumer as far as the Tamil Nadu is concerned. Number two. Number three, for the HT consumer, transformer is within your premises, so therefore you are only the person to connect your load in the transformer. No other persons are available in the transformer, so therefore your voltage profile is going to be very, very good. Rather, if you go for an LT supply, transformer is a common, so therefore the transformer connection is going to be taken by other loads are also connected. If any changes in their load, also that will reflect in the transformer, that will also reflect in your load. So therefore, voltage fluctuation is going to be normally common in the LT consumers. Especially for the daytime, voltage is going to be low. Nighttime, the voltage is going to be very high. This is a common problem in the LT service. You can check, right? For the HT consumer, you have a two-part tariff. We have a two different tariff. For the sanctioned load, they are calculating for how much amount of sanctioned load for the KVA and how much amount of you are utilizing KWH. KWH is going to be energy. KVA is the sanctioned load. So for the KVA, it is a fixed charge. And similarly, KWH, how much amount you utilize, for that you are going to charge. And similarly, you have other charges also applicable for the systems. Okay. Now I will show you one electricity bill, HT bill for you, so that it will be very easy to understand. And I think some of the people does not see the HT bill. So this is the right choice, right opportunity to see the electricity bill. This is the electricity bill of an Inco Survey factory. Don't bother about the names which is available at the top, what they're going to have. Now it is visible, sir? Electrical bill is visible? Can someone tell me whether the bill is visible?
No, sir, no, it is not visible. Billing slide is there, sir. Electricity bill slide is not.
Oh, still you have a billing slide, sir. 1 minute, sir. Now is it visible, sir?
Yeah, now it is visible, sir. Visible.
Okay, thank you, sir. Thank you.
Yes, sir. Visible, sir.
Okay, thank you. Okay. Now the point is, this is a T factory EB bill. You can see it's a HT supply. The name itself indicating it's a high tension consumer. You can see the bill, high tension bill for the month of March 2020. Name is available, GST number. We have this is the tariff. One name, the tariff. You can see the permitted demand. Permitted demand of the company is 250 kVA, right? Permitted demand of the company is 250 kVA, and the other parameters. You can see the very important point. It has a different slabs for consumption. Okay. Now for industrial consumption, it's going to be 6.35 rupees per kilowatt hour unit per kilowatt hour. Okay. And similarly for peak hour consumption, it's going to be 1.27. It's called a TOD, time of day. I will come to the point later. And similarly, if you are coming for the night hour consumption, is going to be a 5% rebate, minus 5% of 0.3175 rupees will be minus. Now, this is the consumption. First, second, third is your consumption pattern. Whereas the fixed charge, I told you that KVA is 250 kVA is the sanctioned demand. For that, 350 rupees is the fixed charge per KVA. Per KVA, we have to pay. Very important point. Very important point is whether you run the factory or not, whether you produce the output or not, doesn't matter. Okay. So fixedly, you have to pay a minimum amount of 350 rupees per KVA multiplied by 90% of your permitted demand. Okay. What is the permitted demand for this company? It is 250 KVA. What is the 90% is 225. Correct? See, it's a 225. So for 225 multiplied by 350 per KVA is going to be 350, which is exactly equal to 78750. I'm having a calculator with me. So therefore 225 multiplied by 350, which is exactly equal to 78,750 is the fixed charge you have to pay, whether you run the factory or not, doesn't matter. Okay, this is always available with you. This is always available with you. That's the first important point. Number two, you have a second, this is the first part of the tariff. This is the fixed part of the tariff. Number two, your consumption pattern. Consumption pattern is different, depend on the production. Depends on the production, the consumption pattern is different. And put together, all will be calculated. Apart from that, you have a meter rent of 3,000 rupees and you have a low PF. See, this company will have a PF, low PF. Compensation for the low PF. This company invite a power factor penalty for not maintaining the power factor penalty. They have a power factor penalty of 4,450 and they have an electricity tax of 5% for the total amount. And put together the cumulative. The cumulative amount is going to be 2,56,000 rupees. So out of 2,56,000 rupees, 78,750 is the fixed charge. 78,750 divided by 78,750 divided by 256,003, which is exactly equal to 30% is the fixed cost. For this company, the fixed charge is 30%. So this is very, very important as far as the electricity is concerned for the HT consumer as well as LT consumer. Of course, this can be reduced. 30% can be reduced to 10% if you operate the system very, very accurately, very correctly, very optimally. Then the percentage of the fixed cost to the total amount paid will be reduced to maximum of 10%. Maximum of 10%. That's possible. But only thing is you need an optimization. You need an audit. You need an energy audit like in your industry to optimize it, right? Now, this is the first page of the bill. Second page of the bill will have TOD, times of different day. Entire 24 hours was divided into 5 different zones, and each 5 different zones are calculated, are recorded in your meter itself. You don't need to do any calculation. Your meter, which is provided or which is installed in the system itself, will be having their own TOD calculations. So each and every slot, I will show you what is the slot and all those things. Okay. In the second page and third page, what is the calculation procedures are available, and for that, what is the total amount of money you are going to pay it. And the fourth page is a compensation page, where how much amount of electricity you use it and other things. Either you can is there any adjustment available in your electricity bill? For example, I told you now, electricity can be purchased from IEX, International Energy Exchange. You can buy, or third party, or captive power plant, or solar power plant, or wind power plant. You can buy from any other sources that can be subtracted here, and the total billing can be calculated based on the system. Number one. Number two, why this company invites power factor penalty? Now the power factor, average power factor for this company is 0.88. Very important point is for HT consumer in Tamil Nadu. I'm talking about the Tamil Nadu. Okay, for HT consumers, they have to maintain a minimum power factor of 0.9, a maximum 1. Okay, for LT consumer, they have to maintain a minimum power factor of 0.85 and more than 0.85. Okay, so if it is slipped below 0.85 for LT consumer, if it is slipped below 0.9 for the HT consumer, penalty will be imposed. There is a separate calculation procedure for the penalty. Okay, I'm not talking about that one. So this company is not maintaining the power factor for a particular month. In the month of May, March 2020, they are not maintaining the power factor of 0.9. So they are slipping by 0.02. So therefore, penalty was imposed at a cost of 4,000 rupees. See, it's 4,400 rupees is the penalty paid by the company for not maintaining the power factor. This is very, very important. Okay. Now, one question will always arise in your mind. Number one, what is the question? So, sir, you told that 0.9 is the minimum power factor to be maintained by HT consumer. If I maintain 0.9, it is good. If I'm not maintaining the power factor at 0.95, I was penalized. Correct. Do I get incentive if I maintain power factor of unity or power factor of 0.95, 0.97, 0.98, 0.99? Do I get incentive? This is the question always you knock your mind. Penalty is available means incentive should be always available. I mean, correct? If incentive is available, penalty must be available. Correct? Now, again, the second question to the participants. In Tamil Nadu, do we have power factor incentive or not? Both for HT consumer as well as LT consumers. Use your chat box and tell me the answer. Okay. Now we will move on to the main slide. Okay. Now, this is represented. This was given by the IC people. I show you our Tamil Nadu bill, and these are all the things which is available. It's a two-part tariff. We have a fixed or we have a variable. We have a variable charges for the energy charges, fixed charges for the maximum demand charge, and sometimes we have a penalty. We have a time of day and a penalty for exceeding the contract demand. Harmonic penalty, as of now in Tamil Nadu, we do not have a harmonic penalty for HT consumers up to 11 and 33 kilovolt. We do not have a harmonic penalty. Whereas for 33 kilovolt and more than 33 kilovolt consumer, the harmonic penalty is available. Right? Then we have an adjustment cost, duty cost, meter rent, and all those things are available. Right? I'm just talking about only for the HT consumer. So far, I'm not discussing anything about the LT consumer. That will be discussed in the process of that. Okay. Now, time of day, I told you your meter will be divided into 5 different zones of the time of the entire 24 day, and this is the zone time. So between 10 p.m. to 6 p.m. zone A is available. When you operate your machine at that time, you will get an incentive of 5% as far as the Tamil Nadu industry is concerned. 5% benefit will be always available. So that will help us help the Tachometer people to flat the demand curve, so that most of the time the daytime will be always higher connected load than compared to the nighttime load. So therefore, in order to give some incentive, the people may shift their load from daytime to nighttime. But sometimes it is not possible. Daytime load can be operated only in daytime, not for the nighttime. For example, in tea industry, you have to operate your withering to take the moisture content from the tea leaf only in the daytime, not in the nighttime. Not possible. Okay. So restrictions are available. So depends on the factory, depends on the process, depends on the application. You can shift your load from daytime to nighttime if the process permits, if the company permits. Okay, B and 9 to 12 it's going to be zone C, and again 12 to 6 6 o'clock it's going to be zone B, and B cover will be this value. Okay, now DOD consumption all the points I just discussed. We come to the point of thermal energy. Small 2 minutes break. Can I take 2 minutes break? Ananya, madam?
Dr. Sivaram,
Madam, can I take 2 minutes break?
Yes, please. Yes, please. I think we'll just announce a break. Is that fine? We'll just announce a break for 10 minutes.
Thank you. I'm back, madam. I'm back. So thermal system again, audible, madam?
No, please continue.
Okay. Thermal system again, it is very simple too for the mechanical people, so don't afraid, because we are going to deal with again 4 or 5 important parameters, not the very bigger parameters. The first parameter is going to be temperature, heat. Okay, temperature is the basic important parameter which will produce the heat. Okay, now temperature can be represented in terms of either Fahrenheit or degrees Celsius. Sometimes you can convert from C to F or F to C. And similarly, temperature will lead to heat, or mainly used for heating in a particular object or water or for any other object that can be used for a process application. Okay. Now, how much amount of heat can be taken by the object or the system can be normally measured in terms of the calorie or kilocalories or megacalories or even some other units also, right? Now, only one formula is going to be ruling for the mechanical engineering or the thermal engineering, that is M into Cp into delta T. This is the only one formula normally applicable for any type of system, any type of thermal system. This is very simple. Mass into specific heat multiplied by how much amount of temperature can be raised from the basic value. So that's called as a delta T. So again, we have a 2 type of heats. What is a sensible heat, latent heat, and all those things. I will show you this point in elaborate manner in the upcoming slides. Okay. Now we have a superheating system, moisture content, weight of the vapor, humidity factor, relative humidity. Those points somewhat confusing, but don't worry, I will tell you in a very simplest way. Another one is a wet bulb temperature, dry bulb temperature. Then if you have an air or water which is flowing inside a pipe, automatically we have a pressure, we have a flow. So when we have a pressure, automatically we have 3 types of pressure. So there's an absolute pressure, gauge pressure, atmospheric pressure, and how it can be calculated, and what is the interlinking between these parameters. And when you have a heat can be produced, means this heat can be transferred through 3 different mediums. One is called C, conduction, another one is called another C, convection, and third one is going to be an R, radiation. So these are all the specific calorific value. Normally, a mechanical component are represented in terms of the calorific value. Energy content. It's very simple. Energy content of that. How much amount of energy content that particular fuel possesses. That's all. Okay. So calorific value either represented in terms of joules or in terms of calorie. Again, sometimes you may be represented in terms of liter, you may be represented in terms of kg, because when it is a solid, then automatically you can go, you will represent in terms of kg. If it is an oil or something like that, furnace oil or oil like that, then automatically it will be represented in terms of the liter. Then again, when it is represented in terms of the liter, carefully you have to convert that into kg, or you can represent all in terms of liter. Okay. And similarly, if it's a natural gas type fuel, means automatically you can go for an cubic normal meter cube. Okay, so it's a volume based. So again, care must be taken what type of unit is given, and similarly what type of unit is given and how it is represented. That's taken into account. Okay. So these are all the very important point. Again, I will go to my slide, so that it will be very easy for you to understand the mechanical concept clearly and very easy. Okay, don't worry, the mechanical thermal components are very easy. I think this slide is going to be visible now, right? So these are all the important parameters, thermal energy basics, which includes temperature, pressure, heat, and all those other parameters. Now, 2 important parameters, temperature and pressure, are the very most important parameters, where the physical quantity that quantifies our common notation of hot or cold that can be represented either in terms of the Kelvin or Fahrenheit, or sometimes going to C. But normally Kelvin representations normally we are not using in India, of course in Tamil Nadu, especially for industrial applications. When the equipment is going to be purchased from some other country or imported from some other country, then we are using Kelvin. But most probably we are using Celsius or as well as the Fahrenheit. Now pressure is a very simple force per unit area. How much amount of force you are applying to a particular object represented for the particular area. That's represented by the force given by a force divided by area is called the pressure. right? Now, pressure can be represented in three different ways. One is an absolute pressure, another is a gauge pressure, and another is an atmospheric pressure. The name itself indicating that absolute pressure measured relative to the absolute zero pressure that can be equated for your vacuum. You can vacuum the entire system and you can measure the pressure. That's called as an absolute pressure. That is a reference. Vacuum is a reference for my measurement. Gauge pressure. You are having a pressure gauge. The gauge indicating the pressure, that's called as a gauge pressure. Normally, the gauge pressure, the gauges, what the digital or analog gauges, normally calibrated for the atmospheric pressure. Atmospheric pressure is going to be taken as a zero value or reference value for your gauge. Now, put together, we have an atmospheric pressure will be surrounding the air surrounding the particular surface or the particular system what we are going to examine it. Okay, now you can very simply, with the help of this diagram, you can very simply understand that you have an atmospheric pressure in the air, you have a gauge pressure in the system, put together is your absolute pressure. Okay, so this pressure calculation, the value of pressure are more important when you are designing a compressed air system or liquid flowing system. So what is the pipe size, what is the pressure, what is the flow, and everything is going to be completely depends on the pressure. Okay, so a simple formula, your system pressure or absolute pressure, both are same. System pressure and absolute pressure will be equal to gauge pressure plus your atmospheric pressure. Now, heat can be converted into one body to another body, as we know that it is transferring from higher temperature to the lower temperature. Again, it is very simple to the electrical. Again, it is very, very simple to the electrical. In electrical, the current will flow from higher potential to the lower potential. Same thing. The heat can be produced, can be transferred from higher temperature to the lower temperature. Only thing, the same. There is no change. Only thing is the variable name is changing. There is going to be current. Now it is going to be a heat. Higher temperature to the lower temperature, heat transferring is going to be taking place. Okay. So the unit for the heat transferring is going to be calorie. Normally, 1 calorie will be equal to 4.187 joules. And we have a sensible heat normally measured. Of course, latent heat also normally measured. Sensible heat will be given by simple formula M into Cp into delta T. I told you mass of the object and the specific heat of the object. How much amount of the heat content the object can able to withstand. That's called as a specific heat. And change in temperature. At what temperature to what temperature you are changing the value. So that's a change in temperature. Now this figure will give you a simple idea of how the material can be changed from one phase to another phase, and similarly one value to another value. Now let us assume that you have a solid. Now you are giving heat to the solid, and when the heat is increased, temperature is also increased. Right? At one particular, let us assume that it's going to be assume that it's a water. It's an ice, or it's an ice in the solid. Now, if you give the heat, what will happen automatically? The ice will melt, try to melt. When your heat is going to be very more than at one particular point, at one particular point and one particular time, the solid will become liquid. Correct? Now, even from this point, if you increase the heat, the temperature will not change. So now the phase changes. Earlier it's a solid, now it will become liquid. Okay, the phase changes. Earlier it's a solid, now it's going to be liquid. But whereas even after if you give the heat, then automatically the temperature will not be changed because it's saturated. This is almost saturated. When the system is saturated, even though if you're giving input, the output will not be there. That's called as a saturation point. So it is saturated at this point, and if you give the heat, the temperature is not that much. Okay. Now, when you give the heat further and further and further, then the liquid will become gas. So automatically at one point of the time, now from this point, if you increase the heat further, now the temperature starts increasing. Now at one stage, the liquid will become gas. Again, the same is going to be available. Okay. So your system or your fuel can be changed in its phases by giving your heat as well as the temperature, right? Now, this is very important point as far as the thermal energy is concerned, especially for the boiler. This is very important because you are producing the steam by the help of water. Am I correct? Now, the water normally in the atmospheric temperature, maybe around 30 degree or 35 degree different. So you are giving the heat to produce the steam more than 100 degree, then the water will become vapor. Water will become gas. Even though it has some water particles are available, but if you give more amount of heat, then the water particle will get reduced and become a super, almost a dry steam. So that's very important for the mechanical engineering process. This is again the same. You have ice. If you give the heat, then it start melting. It will become water. And again, if you give this additional energy, automatically the temperature will be increasing. You are giving more amount of energy, but temperature will be increased from 0 to 100. Now at 100 degree, again it starts changing its phases from liquid to vapor. So from liquid to vapor, for complete vapor, again you have to give more amount of energy. So you are giving 80 calorie for melting the solid to liquid, additional 100 calorie from liquid to become and starting the vapor, again for 580 calorie to become a water into a pure gas or vapor. Now if you extract what you gave, then again this is possible. Forward is possible, reverse is also possible. So if you have a gas, if you take 540 calorie, remove the 540 calorie, it will become liquid. Again, if you remove the 100 calorie, again it will become gas, ice. So reverse is also possible. So in some application you have a forward looping, in some application you have a reverse looping, that's also possible. So ice melting application, ice packing application, reverse is possible. Okay. So that's why I just want to this slide. So the same thing, same slide will be always apply. Okay. Now for the another thermal parameters, these are the parameters. Humidity is the moisture content of the air, how much amount, dew point is also saturation point of the moisture. Relative humidity, how much amount of water vapor available with respect to a saturated point. Relative humidity can be represented in terms of percentage. Normally the comfort level and dew point will be correlated, and relative humidity is also correlated, right? And of course this will be very much useful for the HVAC system. I will tell you in detail about this. Then we have two type of temperature. One is a dry bulb temperature, another is a wet bulb temperature. Sensible heat content in the air vapor mixer, that's called as a dry bulb temperature. But it is if it is accounted your RH also, that is called as a wet bulb. That means you are adding your water content in the air, that also taken into account. That's called that will be called as a wet bulb temperature. The enthalpy of air, how much amount is the energy content of the air, that can be represented by kilocalorie or kg, or enthalpy of particular fuel, that can be also represented by kilocalorie per kg or kilojoules per kg or liter whatever. Density is also very important. It's a ratio of mass to the volume of the system. So it is represented by kg per meter square. And from that you can derive the specific gravity of the fuel. It's a ratio of the density to the fuel of the water. How much is the gravity? So fuel, as you know that the water will have a gravity of 1. So therefore that is taken as a benchmarking. Okay. Now it is very simple. If you get the value of specific gravity of a particular fuel like kerosene, oil, or whatever may be, it may be around 1.21, 1.1, 1.7, 1.4, 0.9, 0.8. What's the meaning of that one? It's very simple. The value is greater than 1, automatically sink in the water. Because the base level is going to be 1. Water is going to be base level of specific gravity of 1. So if anything more than gravity, more than 1, definitely it will sink, because it has a more amount of mass than compared to the water. So there will definitely how denser it is, your particular product. When it is lesser than 1, then automatically it is float on the top. You can see the kerosene, you can see the oil, always float on the top of the water, because their specific gravity is lesser than the water. So therefore, always it is float on the water. Okay. Now energy content, again, the top is not going to be much important. We have represented in terms of the GCV, calorific value, gross calorific value. Sometimes you can also represent in terms of the net calorific value. We don't bother about that one. Okay. So GCV value is going to be the normal user. NCV, sometimes it is used for internal calculations. GCV is always higher value. And the last point are the simplest one. You can convert from one form to another form. 1 watt second equal to 1 joule, 3.6 millijoules equal to 1 kilowatt. 1 calorie equal to 4.2 approximately joules. And similarly, you can 3.6 megajoules divided by again 4.18 equal to 860. That means 1 kilowatt hour equal to 860 kilocalorie. So either way, whether it is in joules or it is in kilocalorie or kilowatt hour, either way, in which form it is available, we can easily convert from one form to another. Watt hour to kilocalorie to watt hour, joules to calorie, joules to kilowatt hour. Easily you can remember only these 3 formula. That is enough. 1 kilowatt hour equal to 3.6 millijoule. 1 calorie equal to 4.2 joules, and 1 kilowatt hour equal to 860 kilocalorie. That is enough to convert from one form to another form. Okay. Okay, I think conversion of energy. Just another 5 to 10 minutes we can discuss. It is visible for the forum. Now, energy conversion, not the conservation. Energy conversion, you can convert from one form to the other form. This diagram will show you how the thermal power plant will converting the electrical energy, and each stage will have an efficiency of the boiler, efficiency of the turbine, efficiency of the generator. Of course, this is too much higher value. Normally, it is not like that. And why we need to have an energy conservation, and why these are important. Why we have to conserve energy? I told you, when you want to conserve energy, is it advantage for me? No, it is not advantage for you. It is advantage both for you as well as the nation. You know that you know that the energy conservation at your side of 1 unit will be equal to 3 units at the generation side. And also, if you conserve energy, then automatically that will conserve the natural resources what we are now using. And you know that 65% of our electrical energy comes from the thermal power plant. In India, I just talked about in India, around 60 to 65% from thermal power plant, that too coal-dominated power plant. So if you consume 1 unit of energy, or if you conserve 1 unit of energy, then equal to 3 units of energy saving at the input side. That is not only saving the energy, that will save coal, also water for washing the coal. So this is the first point. Second point, you know that 1 kilowatt hour of energy will be equal to 0.82 kg of carbon dioxide. Normally, the global warming can be measured. Of course, we are having so many gases coming out of the energy consumption, whether it is going to be electrical or mechanical or whatever it may be, but mostly we are taking CO2 as a benchmarking value. This is different for different fuels. For electricity, I'm just talking about electricity. For 1 unit of electricity you consume will be exactly equal to releasing 0.82 kg or 820 grams of CO2 in the atmosphere. Okay, this is available in the BE website. You can just take it. This is the normal. This is the conventional value. I'm just talking about the conventional value of the CO2 emission when you consume 1 unit of electricity. Rather, if you think in the different way, if you conserve 1 unit of electricity, you are saving 0.82 kg of CO2 in the atmosphere. Now it is our responsibility to reduce 1 unit of electricity at your site and multiply by number of students, number of faculty, number of institutions, number of responsible persons. Then you can imagine how much amount of CO2 can be reduced. That is why the government of India, state government, environmentalists, energy professionals are requesting all the faculty members, please teach this information to the students such that use the energy judicially, not lavishly. That's the first point I want to tell you. Number 2, it will be giving advantage for the person who is using that, also for the nation. So you are also helping for the nation. That's the second important point I want to tell you. Right? So that is why we are mainly focusing about this energy as well as environmental. Now it is linked. Earlier, environmental was separate, energy was separate. Now it is linked. Environmental, energy, ecosystem, biodiversity, everything was linked completely. Greenery, everything is completely linked. We are doing energy, environmental, green audit for so many engineering colleges and arts and science colleges. We are linking all the parameters. Greenery parameters, environmental parameters, energy parameter, linking together, putting a separate table called CO2 balance sheet, and what is the CO2 of the particular object, particular system, or particular institution, or particular industry, and what are the CO2 nullification measures they are having, and also how to nullify the CO2 measure up to 0 value, and how to become a net zero carbon building, net zero energy building, net zero positive building, net zero water building. So those things are coming in a bigger way, and we are now teaching in this point to the other industries as well as institutions. So we come to the point of energy management. as we know that managing the energy, we have two different cases. One is an energy conservation, and one is an energy efficiency. Energy conservation use less amount of energy for the same application, whereas energy efficiency technology upgradation for the that means you can use the application is going to be same, but instead of using an older equipment, you use the newer equipment, energy efficient equipment. See, we will discuss those points in later. Okay. So for successful implementation of the energy management, we have 4 pillars. One is technology, another one is a monitoring system, strategy, and top management. And we have a monitoring system. Normally, we as a BE certified people, normally we tell that unless otherwise, if you are not monitoring, you can't able to control the parameters. So monitoring is very important, whether it's going to be an electrical parameter or mechanical parameter, whatever maybe you have to monitor how much amount of energy is consumed in a particular building or particular system or particular equipment or particular plant. Then only you must know whether it is going to be correct or wrong. Then only you may come to an understanding that whether is a possibility for saving the energy. So first point is monitoring. So measure to monitor or monitor to measure, or verification is going to be taken care by monitoring the system. So you need to properly monitor your system, and once you monitor, then you could go for an energy performance indicator whether the system is going to be very properly working or not. When you have a monitoring performance indicator, then you can go for an assessment and how much amount of energy you can able to save it. That is the parameters. Okay. Now you can see the energy performance indicator at the plant level as well as the process level. How much amount of energy I can utilize. That can be represented by 2 different indicators. One is total energy consumption per month, how much amount of energy you consume. That's the first indication. Second indication, for one particular object, how much is the energy I consumed for the particular object to produce how much amount of pieces, how much amount of output. So these 2 are 2 important. One is a specific energy consumption, another one is a total energy consumption. This can be easily compared with the 2 different examples. I have a car, how much mileage it gives. For 1 liter of petrol, how much mileage it gives. And similarly, if a boy or a girl are studying in a system, how much amount of mark I got from a particular examination, right? So I will show you some of the simple indicators that are mainly used for calculating the. Sorry, this is not required now. I will tell you. Yeah. This is what somewhat useful, and I will also show you some of the good slides about the specific energy consumption. Right? You can see I have a pump. So in that pump, I have an electricity will be supplied from input, and I'm getting the output of the water. So specific energy consumption, how much amount of energy you are getting from the output, and how much amount of energy you are giving as an input. Similarly for the boiler, and similarly for the blower. Only thing is the way the parameter is different. Electrical input is the electrical input and mechanical output. Okay, so energy consumed divided by how much amount of energy input. Okay, now I will give you a simple example. You can see a boiler. You are giving a boiler input to the boiler is a biomass. Okay, now biomass is the input, and you are giving to the boiler, and the boiler will give a steam. Now I'm just only talking about the specific consumption of the boiler, not the internal system. Okay, the boiler will give 4,000 kg of steam per hour, or 4 tons per hour. Okay, now this is the boiler output. Now what is the boiler input? I'm giving a biomass input. Biomass pellet or biomass sticks having an energy content of 1124 kg per hour. I'm giving. For that, I'm getting 4 tons of steam output. So what is the specific energy consumption? It is 4,000 divided by 1124. Both are same unit, kg per hour. Okay, that means for 3.55 kg of fuel, for 3.55 or approximately 3.6 kg of fuel, you will get 1 kg of steam. That's all. It's very simple. Okay. So for 1 kg of fuel, so 3.6 kg of fuel, you will get 1 kg of steam. Or rather, you can try 1 kg of fuel, how much amount of steam can be generated. That also you can calculate from the specific energy consumption. Right. Now the same is going to be applicable for the chiller in the AC system. I'm getting both are represented. One is represented in terms of electrical, other one is represented in terms of the mechanical. or the chilling efficiency. Output is going to be an 85 TR, and the input is going to be an 85. So it's 85 kilowatt divided by 87, which is equal to 0.97. That means 1 TR, one tonnage of refrigeration capacity, or 0.97 tonnage of capacity, I require 1 kilowatt of power energy. This is your specific energy consumption of a particular system, right? So you have an proper benchmarking for this, and all the parameters we will discuss. Now it is 11:30. We will have a short break of 15 minutes. We will come exactly by 11:45, and we will discuss the specific energy consumption and other parameters after the break. Okay. Now is it work for you? Madam, is okay? Hello. Madam, is it
Okay,
okay?
sir.
Okay.
Okay, sir.
Break of 15 minutes, and we will come back. Hello. Ananya, madam?
Yes, Dr. Sivaras.
Madam, can I start now?
Yes, please. I think some participants have left the room. I'll just put it in the WhatsApp group. We can start in 2 minutes.
Oh, okay, madam. I'll wait.
Sivarasa sir, good morning sir.
Sir, good morning, Sivarajan, sir.
சார் அந்த ஏடிசி லாஸ் பத்தி கேட்டிருந்தீங்களா சார்? அந்த உதய வெப்சைட் பார்த்தேங்க சார்.
பாத்தீங்களா சார்?
கேரளா தான் கம்மியா இருக்குங்க சார். ஜார்க்கண்ட் வந்து கூட இருக்கு.
எக்ஸலென்ட் கரெக்டா அட்ரஸ் சார். கேரளா less than 5% கரெக்ட்டுங்களா சார்?
அதுல 10 பாயிண்ட் காட்டுதுங்க சார்.
10 பாயிண்ட். ஓகே மேபி இப்ப ஜாஸ்தியா இருந்துக்கலாம். நான் ஒரு 3 வீக்ஸ் பேக் வந்து ஒரு 5.2 சம்திங் இருந்த மாதிரி இருந்தது. ஹையஸ்ட்ங்க சார்?
சரிங்க சார். ஜார்க்கண்ட் வந்து 96 கிட்டங்க சார். ஜார்க்கண்ட்
இல்ல சார், ஜம்மு அண்ட் காஷ்மீர் அதிகமா இருக்கு. இப்போ ஒரு தடவை செக்
அதோட ஜார்க்கண்ட் 96 இருந்துச்சுங்க சார்.
அப்படியா? சரி நான் பாக்குறதுக்கு செக் பண்ணி பாருங்க சார். கரெக்ட்.
ஜம்மு வந்து 60% இருந்துச்சு.
60%. ஆமா, 60% இருக்கு. கரெக்ட். ஏன்னா அது வேல்யூ அதிகமா இருக்கறனால அங்க வந்து பட்ட இந்த கார்ஷெட் டவர்ஸ் அதிகமா இருக்குங்க. அது நார்மலாவே லாசஸ் அதிகமா இருக்குங்க. அதனால அந்த இஷ்யூ இருக்கு சார்.
சரி. என் நேம் அசோக் குமார் சார். நான் தியாகராஜ இன்ஜினியரிங் காலேஜ்ல எலக்ட்ரிக் டிபார்ட்மெண்ட் ப்ரொஃபசர்.
வெரி குட் சார். நல்லா இருக்கீங்களா சார்?
நல்லா இருக்கேன் சார்.
ஒரு சரவணன் சார்
வாட்ஸ்அப் குரூப்ல இருக்கேங்க. நல்லா இருக்கேன்.
சரவணன் சார் ஒரு 2 டிசி தான் சார், மதுரை.
ஆமாங்க சார்.
சரவணன் சார் நல்லா இருக்காங்க சார். அவர் எம் சரவணன் சார், வி சரவணன் சார்.
2 பேரும் நல்லா இருக்காங்க சார். நல்லா இருக்கு.
கேட்டதா சொல்லுங்க சார். சிவராஜன் சொல்லுங்க சார். தெரியுங்க சார் உங்களுக்கு?
தெரியுங்க சார். நான் உங்க குரூப்ல நானும் மெம்பரா இருக்கேன் சார். நீங்க இருக்க குரூப்ல.
ஓ, வெரி குட் சார்.
வாட்ஸ்அப் குரூப்ல இருக்கேங்க சார்.
வெரி குட் சார்.
சார் இந்த முடியறப்போ அந்த இது எனர்ஜி ஆடிட் பத்தின ஒரு அவேர்னஸ், அந்த கோர்ஸ் எடுக்கிறது, அந்த பத்தின இன்ஃபர்மேஷன் கொஞ்சம் ஷேர் பண்ணுங்க.
அது வேணா ஒரு 10-15 மினிட்ஸ் வேணா எடுத்துடலாங்க சார். அது நாளைக்கு எடுக்கலாமா, இன்னைக்கு எடுக்கலாமா சார்? அது
உங்க சௌரிங்க சார்.
எடுத்துடலாங்க சார். தனியாக ஒரு ஸ்லைடே வச்சிருக்கேன். நான் ஒரு 2-3 ஸ்லைடு இருக்குதுங்க சார். ஹவு டு பிகம் எனர்ஜி ஆடிட்டர், என்னென்ன குவாலிஃபிகேஷன், அது இருக்குதுங்க சார். நான் தரேன். அது ஒரு சின்ன பிரசன்டேஷன்.
சரி,
நல்ல ஐடியா.
ஓகே,
அருமைங்க சார்.
நல்லா இன்ஃபர்மேட்டிவா நிறைய இருக்குங்க சார்.
தேங்க்ஸ்ங்க சார்.
கொஞ்சம் ஸ்பீடா இருக்குங்க சார்.
ஆமாங்க சார். அது ரொம்ப நிறைய இருக்குதுங்க சார். 169 ஸ்லைடுங்க சார் நீங்க ஒரு நாளுக்குள்ள. அது இருந்து நிறைய மாறி இந்த பக்கம் வரனால எனக்கு கொஞ்சம் டைம் எடுக்குதுங்க சார். ஆக்சுவலி இன்னைக்கு இப்ப வந்து பாட்டினா வந்து நம்ம அந்த எனர்ஜி மேனேஜ்மெண்ட் முடிச்சு பவர் சிஸ்டம் ஆரம்பிச்சிருக்குன்னு நம்ம ஒன்னும் இதே முடிக்காம இருக்கு. இன்னும் கொஞ்சம் ஏன்னா இனி வரதெல்லாம் கொஞ்சம் காமனா தான் இருக்கு. நான் டேரக்டா கொஞ்சம் கேஸ் ஸ்டடிஸே வந்து டேரக்டா காமிச்சலாம்னு பாக்குறேன்.
சரிங்க சார். நல்லா இருக்குங்க சார் பிரசன்டேஷன்.
தேங்க்ஸ்ங்க சார்.
சார்
அப்புறம் அந்த இது கேட்டேங்க சார், பவர் ஃபேக்டர் பெனால்டி. அது இன்சென்டிவ் இருக்க மாதிரி எங்க இன்ஃபர்மேஷன் கிடைக்கலங்க சார்.
இல்லைங்க சார், தமிழ்நாட்டுல இன்சென்டிவ் இல்ல பெனால்டி உண்டு, இன்சென்டிவ் இல்ல. ஆனால் இப்ப நம்ம
இருக்குங்க சார்.
எங்க சார்
மகாராஷ்டிரா இன்சென்டிவ் இருக்கா சார்? மகாராஷ்டிரால
இன்சென்டிவ் கிடையாது. இன்ஃபேக்ட் மகாராஷ்டிரா வந்து கேவிஏ பில்டிங் போயிட்டாங்க. ஆனா பக்கத்துலயே ஒரு ஸ்டேட்ல வந்து பட் வந்து இன்சென்டிவ் இருக்கு. எகைன் அது உங்களுக்கு இதா சொல்றேன் சார்.
கேரளாங்களா சார்?
இல்லைங்க சார், இல்ல யோசனை பண்ணி சொல்லுங்க சார். பாண்டிச்சேரி கரெக்ட்.
சரிங்க, ஓகே,
நான் இன்ஃபர்மேஷன் சொல்றேன். நல்ல ஐடியா, நல்ல, வெரி குட்.
தேங்க்யூ சார்.
ஆரம்பிச்சிடலாங்களா சார்? மேடம்
Sivarasu, I think you can begin the session.
Okay, madam. Thank you, madam.
Thank you.
Madam, visible, madam?
Yes.
1 minute.
Taking some time. Yeah, visible now.
1 minute, 1 minute. Okay. Welcome back to all the participants for listening my lecture after this short break. We are move to the next points. Energy performance assessment techniques, how to improve our energy performance. First of all, we have to find out what is the indicator which is going to be available for the given system, and then we have to find out the energy performance assessment. Then we have to improve the systems. Okay. Now again, this is not simple because energy management is a separate technique. As you know that there is a separate ISO system is available. ISO for 9001 is for quality management system. ISO 14000 is for environmental management system. ISO 50001 5001 is for energy management system. So in the energy management system, if you follow energy management system in your industry, or if any industry, if you are going for energy auditing, that having ISO 50001, then they need a very important point called data should be available. Particularly, they have to have all the historical data, especially the motor, machines, generator, transformer, compressor, furnace, all the things they have separate data should be available. And what is the benchmarking value? What is the design value of the particular system is to be operated? For example, I will tell you one simple example of generator. You know, the people are from mechanical engineering and electrical engineering know that one important parameter in the generator is an UPL, unit per liter. That means if you feed 1 liter of diesel, then how much amount of unit it is generated? That's called as an UPL. So normally this UPL is governed by so many parameters like what loading percentage, energy content in the diesel, what type of diesel you are using, whether you are using normal diesel or high speed diesel. Similarly, what is the density of the fuel? Similarly, what type of load you are connecting, whether it's a non-harmonic load or harmonic load. So those parameters are available. But the designer or the supplier or the OEM, original equipment manufacturers, they gave an ideal UPL value for a particular load condition. For example, 50% load, this must be the UPL. 80% load, this must be the UPL. So those values they gave. But how many of us we are regularly checking? In our college, we have a generator. Absolutely, none of the college will not have a generator. 99% of the colleges will have a generators. Even electrical people or mechanical people, have anybody gone to the DG set and whether they verified the UPL value for each and every run or each and every month or each and every year at least? No. So this is the problem. We need a benchmarking value. Benchmarking value normally taken by our reading or given by the designer reading or supplier reading. Then if it is not met, for example, if the benchmarking value is 3.5, for example, one liter of diesel will give 3.5 unit of electricity for this much percentage of the load. Now you are measuring with the help of some meters, you are measuring it at the load condition. You are found that you are getting a value of 3, not 3.5. So why is the difference between 3 to 3.5? Where the 0.5 goes? So that you need an auditing. Okay, so in that way, each and every equipment, each and every system, each and every process, definitely we need a proper historical data or collection of data, or we need to collect the data. Then we have a benchmarking value. If the benchmarking value is not matching with the collected data, then we need an audit. Then only we go for an audit, right? So normally the specific energy consumption deals are compared with the production. How much amount of production is available, and for 1 kg of or 1 ton of output, how much amount of energy is taken. So that is called as a specific energy consumption versus production. I will show you in the later slide with the help of one case study of a tea industry or some other foundry industry also. I will come to the point of the energy audit. we know why we go for an energy audit. Normally, most of the industries are asking us to conduct energy auditing because they want to know where the energy is used. Number one. Number two, whether the energy is properly used or not. Number two. Number three, whether is there any possibility to save energy for the same production or increase in production. So these are all some of the scope they will give by the industries. So based on the scope given by the industries, we conduct the energy auditing. Basically, we have two types of energy auditing. One is an internal, another one is an external. Internal means by the internal people, they will do the auditing based on their equipment, based on their knowledge, based on their data. They will do the equipment auditing. External auditing is conducted by external person, external agency. Normally, it is referred to conduct internal audit first, then find out the gaps. Sorry. Then implement the recommendations and get the result. If the result is not on par with your paperwork, then you can call for the external expert to get the opinion or for the external audit. Okay. Now, again, we have in external audit we have three types of energy audit. One is a preliminary energy audit, and second one is a target audit, and third one is a detailed energy audit. Preliminary energy audit means we are not using any meters. Rather, we will go to the industry or go to the institutions and we will look around the energy consumption pattern of each and every equipment by just visiting the site, discussing with the people who are in the energy team, and analyzing the energy bills, electricity bill, petrol bill, diesel bill, like that. So we are analyzing the bill and we can give some suggestions without any measurement, without any observation. We are giving some recommendation based on our field visit, pre-visit. So that's called as a preliminary energy audit. Targeted audit is exclusively for a particular system. For example, 3 weeks back, we went to one industry in Hosur where they are manufacturing a very huge amount of batteries for vehicle as well as automobile application as well as for UPS application. Okay. Now their energy consumption is, I'm talking in terms of rupees. They are paying a bill of 4.5 to 5 crore rupees per month. Don't shock, it is per month, not for the year. 4.5 to 5 crore per month. Their LPG consumption is 180 metric ton per month again. Okay, so they want to do only electrical audit, not for the other things like LPG. So many things they don't want. So they want to reduce their electrical energy consumption. Then later they go for an thermal system. So that's called as a target audit, target energy audit. One particular section, one particular machine or one particular system audited and checked for the conservation. Then detail audit. Detail audit conducts all. We need a measurement, we need a system, we need a equipment for all type of measurements, and taking the measurements for based on the operating time of the equipment. Then we conduct a detailed audit. Then we will give a report as per the BE guidelines. What are the instruments are used? As most of the people will know that we have two type of sets of instrument. One is for electrical measurement, another one is for mechanical measurements. For electrical measurements, normally we are using a power analyzer, power quality analyzer, or power analyzer, or load manager. So many names are available. That can measure the voltage, current, power factor, power quality measurement, power quality, active power, reactive power, up to 400 variables can be measured with the help of a power quality analyzer. Number one, when you buy a power quality analyzer, keep remember what type of current lamp you are using. Okay, what type of current lamp you are looking for. The first important point, right? Because when you're buying a power quality analyzer, normally the people will go for, or the management will go for a lower quotation. When the quotation is going, when the equipment is lower, or when the specification is lower, then you can't able to take readings in much higher systems. Rather, you can keep your equipment, that's all. But it will not fulfill your auditing needs. Okay, so as you know that the people who are selling these meters will have different options, options. If you want 3000 ampere current CT, then this is the cost. When you go for a 6000 CT, this is the cost. So likewise, but you have to clearly identify which equipment is going to be best suited for your own application. Okay, if you buy 6000 CT, the cost is going to be very higher, but you don't get the order for the 6000 CT, means then the dead investment. And similarly, if you go for a 3000 CT, but you are getting order for 6000 CT, then automatically you can't able to do audit for the 6000 CT system. So carefully you can buy the equipment. What is the option available? What is the best option for you? So that is going to be taken care of. Not only for the power quality analyzer, all thermal imager, even a single clamp on meter that also were having voltage measurement, current measurement. Even some companies are having a clamp on meter with harmonic measurement also. Okay, again the CT ratio is going to be different. So carefully you can select the equipment. So before buying any equipment, take the one trial run, okay, or a demo in a pure system. Then analyze what are the options are available, how to take the reading, how to store the reading, how to retrieve the reading, how to manipulate the reading with the help of a software or the system itself. So those things you can take a demo before buying any equipment. Similarly, when you buy an equipment or a sum of equipments, you can form a separate group. In that group, you can invite one external member who are very well vested in this equipment handling system. So get an opinion from those people also. So that is also very important for whenever if you're buying anything, right? Now you can have this is a flue gas analyzer. Flue gas analyzer mainly used for measuring the chimney flue gas. That is going to be a very important parameter for optimizing the boiler, furnace, even generator also. We are having a generator in our college, but how many people are conducting the flue gas testing regularly at least every year? But I know one college which has keep on every year they are conducting flue gas test for 3 different generators they are having. One is 450 kV, another one is 550 kV, and third one is going to be 800 kV. So these are the three DG the university having, and they are regularly conducting the flue gas test from a third party. I'm not saying that this is very important, but it is also very common factor for conducting the flue gas testing for your equipment, right? So flue gas analyzer. Then you have a thermometer. This is only measuring the thermal temperature only, not the thermal image. Thermal imager is different. Thermometer is different. This is an IR thermometer. It's a non-contact type. Within a close proximity, you can pass on the IR light to the object where you're going to measure the heat, and that will be displayed, right? Then tachometer, we have a digital, similarly analog. Sometimes you can have a contact type. Sometimes you can have a non-contact type also available. So based on the system, based on your utility, you can go for an either contact type or non-contact type. Now, most of the companies are having both options in the same set. Lux meter, measuring the illumination level of a particular place. Now it's a very handy equipment which will measure in terms of lux, in terms of candela, in terms of other parameter, other units. Depends on the meter. And now I saw one company, Lux Meter, which has at least 25 storage facility available in the system. Now, ultrasonic flow meter to measure the flow of a water or liquid or oil, whatever maybe. This is the thermal camera. As you know, the thermal camera is entirely different from the thermometer. Thermal camera is going to be somewhat costlier than compared to the thermometer, which will give the complete picture on of the image. Not only picture, it will also show where the temperature is higher in terms of the color palette. Then we can easily identify the temperature, higher hot spot of the system very easily. Normal human eye will not detect, whereas the thermal eye will detect the system very easily. As you know that most of the airports are now fitted with an IR thermal camera. Now this thermal camera, again, the range is available. How much temperature is you are going to measure it? If you go for an only 350 degrees centigrade, lower version is enough. But if you go for a higher version, for example, if you want to measure the molten metal of an cast iron, then you need a 1200 or 1500 degrees centigrade capacity. So again, if you go for a normal mode as well as the video mode, sometimes video mode is also available. You can record the video mode whenever it is required. So again, the cost is going to be somewhat higher. Leak detector, it's an ultrasonic wave pass on to the system like a flow meter. It's an ultrasonic wave that will detect the compressor air leakage. Now, sonic meters are available. Instead of leak detector, sonic meter is available in one brand that will show you the image where the air leakage is available. And this is the pitted tube, mainly used for measuring the static pressure in the air compressor pipeline. We have two type of tubes will be coming out. One is fitted with the probe, another one is fitted with the one is fitted inside the pipe, other one in the outside periphery of the pipe, so that what is the differential pressure between the inner portion and outer portion. So based on that, how much amount of CFM, cubic feet per meter of free air delivery by the compressor can be easily taken. So apart from that, we have so many meters are available. I can tell you so many meters listed in the energy auditing application, like wood moisture meter. We are having a wood moisture meter to measure the wood of measurement of the wood. Then we have a particulate meter for measuring the clean air condition of a particular room, HVAC applications, and we have an indoor air quality equipment to measure the almost 9 parameters, especially CO, CO2, and all those things, right? Then we go for the topic before the lunchtime is the power system. Power system is going to be almost critical power system for the things. Already we discussed this point earlier, so therefore it is very easy for me to complete that topic. We have a contract demand, we have a connected load, we have a maximum demand. I show you one simple example. This bill already I show you, 100 electricity bill I show you. This already again we discussed it. Time of tariff. Okay. So from this point we will move on to the slide, which will give you an insight about the power system. Please bear with me 2 minutes. 2 minutes. I will change my slides. I will come back to you. Yes. Now I think it is visible now. Visible, sir?
Visible, sir. Visible.
Okay, thank you. Now, previous discussion, I told you that electricity is not generated then and there itself. I do not have a power plant in Coimbatore. I think you also not having a power plant in your own city. We may get the power from somewhere else, generate somewhere else, and we are enjoying the power through the transmission and the distribution system. And I'm representing here generation to the load point with the help of a different equipment. I'm sorry, all the equipment are not listed. This is only an SLD of an important equipment. On the top, I'm having the efficiency of all the system. 80% efficiency, the generator, 99% transformer, 80% transmission line. Again, we have a step down transformer, 99 sub-transmission, distribution, all. Now, if I cumulate or cascade, what is the total efficiency from this point to end point? 0.8 into 0.99, which is equal to 44%. The cumulative cascaded efficiency from the generation point to the end user is approximately 50%. That is why I told you, if you save 1 unit of electricity, which is exactly equal to saving 2 units of electricity in the generation point, right? This is I'm lavishly I'm putting. Now I'm from the generator point of view. I'm not including the turbine. I'm not putting the boiler. So if I put all the system and the input of the boiler, then the total efficiency is going to be only one third. It is around 30 to 35% you will get. So if you say 1 unit of electricity at your side, which is exactly equal to 3 units of electricity at the generation side. Now in the bottom, we can have a figure that is represented by a report called Energy Statistics Report, which is released by the Ministry of Power every year. This is the 2020 report. 2021 report is also available with me, but I request the participant to get the report from the net. It is freely available. So Energy Statistics Report 2022 says that, so the total consumption of electricity in the India, including all the power plants, state power plant, central power plant, private power plant, all the power plants, including the all type of energy, you can see the industry will consume 42%. We don't bother about the industry because it is available. But you can see the domestic sector 24%, agriculture 18%, commercial 8%. Now we can cumulate agriculture, domestic, and commercial, which is almost equal to industry. So we need a big work to reduce our energy consumption for the domestic, agriculture, as well as commercial. That is why this type of programs are keep on running. So domestic, agriculture, and commercial, which is almost equal to industrial consumption. So therefore, care must be taken to reduce our energy consumption. Right? Now this is the tariff of LT service in Tamil Nadu. I show you the HT bill earlier. Now it is time for discussing the LT bill, LT power system. Okay. So this bill is applicable from 2016 onwards. So far it is not changed, but government is having a move to change the electricity bill because of after forming the new government. Now from 2016 onwards, this is the electricity bill is used for Tamil Nadu consumer. First one is going to be dedicated for HT consumer. HT consumer, we have a different type of tariffs. Of course, any consumer, any colleges under HT, they will come in 2B, section 2B, section 2B, private educational institutions. Okay, I don't know whether you are in HT consumer or LT consumer. If you are in HT consumer, you are in the tariff 2B. You can check your EB bill, and EB bill shows that you are tariff 2B. So what is the tariff for the education institution? If it is if the college is in high tension, for energy charge 6 rupees 35 paise per kilowatt hour, and for fixed charge 350 rupees per kVA. Okay. Now this is the tariff paid by the consumer. This is the tariff proposed by TNERC at the time of implementation. Okay. TNERC means Tamil Nadu Electricity Regulatory Commission. Okay. So this was proposed and this was followed. Actually, proposal is higher than compared to the followed. Okay. Now government is subsidizing some of the systems. For LT consumer, 1A is for domestic application, household application. In home, in Tamil Nadu, we are having 4 slabs. Slab number 1, 2, 3, 4, 1, 2, 3, 4. For 100 unit, it is completely free. For 200 unit, first 100 unit is free. For the second 100 unit, 1 rupees 50 paise and fixed charge of 20 paise. And if it is fall on the third category, first 100 unit is completely free. Second 100 unit, 2 rupees. And the remaining 300 unit is 3 rupees. The fixed charge is 30 rupees per service or one unit service. If your consumption is more than 500, then first 100 is free, second 100 is 3 rupees 50 paise, third 300 rupees is 4 rupees 60 paise, more than 500 is going to be 6 rupees 60 paise, fixed charge is 550. This is for others. If your college is LT supply, then you are in again LT2B2. See, LT2B2, private education institution and hostels. Your charge is 7 rupees 50 paise per kilowatt hour, 120 rupees per kilowatt. You are also having the fixed charge. LT or HT doesn't matter. You have a fixed charge. It is always available. Only thing is, for HT it is 350 rupees. For LT it is 120 rupees per kilowatt. That's all. Okay. And similarly for HT it is 6 rupees 35 paise. For LT it is going to be 7 rupees 50 paise. Okay. So this is for all type of consumers are listed here. It is available in the website itself. You can take, or I can forward to the group. You can also get it. That is already we discussed this point. TOT slots. Discuss. Now we will go for an LT consumer in Tamil Nadu. I know most of the people will know this, but if anybody not knowing this, this is the Varaprasada for the Tamil Nadu consumer, especially for the LT service. Okay, so for LT service, you can go to the Tamil Nadu Tangentco website and you can go to the bill status website. You can see your bill. Not only your bill, I can also see your bill if I know your number as well as mobile number. I will show you how you can be able to see your electricity bill in the website. Okay, now you can go to the Tangentco website here, tangentco.gov.in. Then you can click on the bill status, and it will give this page. So in this page, the entire Tamil Nadu was divided into 9 different regions. I will show you. This is the 9th region. Okay, Chennai North, Central and North, first one, Viluppuram, Coimbatore, Erode, Madurai, Tiruchi, Tirunelveli, Vellore, and Chennai South. So South include the Chengalpattu also. Okay, now you can choose in which area you are from, which is available in your EB bill itself. Your complete service connection number, SC number, is available in your EB bill itself. From the EB bill, you can take whether 1, 2, 3, 4, 5, 6 or whatever may be. Okay. Now you can choose the appropriate. I will go to see. I can choose 3 because I'm in Coimbatore. Then I will type all the number which is available in EB bill 056 005 275. This is my service connection number. Then I will also type my mobile number which is connected to this EB number. That is very important. Okay, so you need to connect your mobile number earlier. Already it is connected. To your EB number. So that mobile number has to be put, and you can put the captcha. And if you put proceed, then automatically it will show the entire bill of the particular person. You can see my bill. It is SR Sivarasu, correct? My consumer number 03 056 005 275. What is the meaning of that word? 03 is my region. Already we saw it. What is 056? 056 is Chinniyambalayam area. This is my section. My section office is in Chinniyambalayam area. What is 005? 005 is my distribution area. My Irapatti is my distribution area. 275 is my consumer number. Okay, so there is a meaning for everyone. Okay, so that you have to tell to your students as well as the faculty members, I know. Okay, so not only the first page, I will also see all the month EB detail. complete EB detail for the past 2 years or 3 years, even sometimes 5 years EB bill also available. How much amount of energy I consumed, how much amount I paid, is there any penalty I paid, everything is available in the website itself for only LT consumer, only for Tamil Nadu. I don't know for the other states. For HT consumer, it is not possible in Tamil Nadu, but it is, the work is going on. Work is going on to digitalize all the HT consumer bill, right? That's the point I want to tell you in the EB bill itself. Then I have specific energy consumption for the industry. Okay. Specific energy consumption for the industry as far as the production is concerned. I will take the specific energy consumption in later. Don't worry, because I have a separate good slides will be available. I will tell you why it is. Then some other important terminology called power factor, which is a very important. So far, we discussed with Professor Ashok Kumar sir. He told that there is no incentive in Tamil Nadu, sir, and we have a penalty. Of course, earlier we have an incentive, but not now. So earlier we have an incentive, so automatically all the people put a power factor capacitor to improve the power factor. Then automatically system power factor is improved. So yeah, incentive must penalties are always available. Penalties always available. Okay. Now, if you are not maintaining the power factor, you will be penalized. But if you are maintaining a good power factor, you are not appreciated. But it is our duty to maintain a good power factor. Why? Because if you maintain the good power factor, that will be good for your entire system. I will tell you what is the reason why we have to maintain a good power factor. Right. Now, power factor will terms only when the system is going to be AC, not for the DC. For DC system, we do not have a power factor. Only thing is for AC, we have a power factor. This is the simple example where we have a power factor explanation. I think most of the people will know different type of figures to express the real power, reactive power, and the total power called as an apparent power. And the real power is the only useful work done by the system, whereas the reactive power is required to establish the system. Combined together is called as a kVA, right? Now the difference between the ratio between kW by kVA is your power factor. That's a very simple. Okay. So if kW is going to be very lesser and kVA is going to be very higher, then power factor is going to be lower. I can have a very simple example given by the people. See, I have a kilowatt which is equal to 812. And my operating power factor is going to be 0.9, and my total, if it is 0.9 means automatically my total kVA is going to be 900 kVA, right? Now this 900 kVA is now available, or I'm connecting in the transformer for getting a power of 812 kilowatt. Okay. Now Tamil Nadu is charging only for kilowatt hour plus kVA as a fixed charge, right? Now, assuming that if you are a HT consumer, and transformer is within your premises, okay. Now you are operating the power system by 0.9, then your connected load as of now is going to be 900 kVA. Assuming that the transformer capacity is 1000 kVA, then how much amount of load you can able to connect? 1000 by 900, only 100 kVA you can additionally connect, because already transformer is 900 kVA, 90% it is loaded. Okay. Now what I'm going to do is I'm connecting a capacitor to improve my power factor from 0.9 to 0.95. Okay. What will happen? What will happen if I connect a capacitor to improve my power factor from 0.9 to 0.95? When I improve, my kilowatt will not change because it is completely independent. Rather, if I improve the power factor, the angle difference between these two will be get reduced. So that is why my kVA will get reduced. So earlier 100 kVA is the balance to be connected. Now it will become 148, almost 150 kVA. You can able to connect it. Okay. If you are a HT consumer, you have a cushion to connect more 50 kVA into a transformer. Now you can think for the LT consumer. I told you LT consumer does not have a transformer. It's a common transformer feeding to you as well as to other consumers. So if you are not maintaining the power factor, then transformer will be loaded. Am I correct? Then more number of consumers are not able to connect it in the transformer because of you are not maintaining the power factor and the system is not maintaining the power factor. Okay. Now, if the system is maintaining the power factor of almost unity, almost 1 or almost 0.99, then more number of capacity can be added in the system. This is applicable for generator also, but most of the people are not connecting capacitor in the generator. But I recommend to connect a capacitor the generator to improve the power factor from 0.8 to 0.95. It is good. It is good for the transformer, and that will also improve your UPM. Okay. We haven't separate people are available to connect the capacitor DG, and they have a good result with them. And more probably they got 400 to 500 installations in their basket. Now this is the reason why we have to connect the capacitor at the inputs, right? So the main important point is we do not have an incentive, whereas we have a penalty to avoid the power factors, right? Where I have to connect the power factor. The things we will discuss one important slide. 1 minute. Okay. This is the presentation I gave to. Okay. Now you can see the EB bill. You can see this is one of the T-industry EB bill. Okay. 1 year EB bill was analyzed. Normally for energy auditing, we are using one year EB bill analysis. The first important point is what I'm going to do is why the power factor is going to be very important. See, DPF, disincentive power factor. Not maintaining the power factor. Why? What is the power factor of this industry? 0.82. It's a HT industry. For HT industry, how much is the power factor to be maintained? 0.9. 0.9. For the month of November, 0.82 penalty, 48,000. 0.89, 4,000. 0.93, no penalty because more than 0.9, so therefore no penalty. 0.88 penalty, 8.82 penalty, 83 penalty, 70 penalty. 70 invites a penalty of 1,63,000. 64 will invite a penalty of 1,18,000. Again, I told you the penalty value depends on the unit consumed. Unit consumed based on the unit consumed. Okay, sorry. Where is the unit consumed? Sorry, I think the unit consumed is not here. Okay. How much amount of unit is consumed is the very important point. So based on that one, you cannot correlate. This is 0.64. This should be higher. So based on the higher capacity, higher kilowatt hour, the penalty was imposed. That's we are having a different formula. So totally, this industry invites a power factor penalty of nearly 5.7 lakhs. 5.7 lakhs in a year. 1 year, it invites a penalty of 5.1. When you have a penalty, your system is wrong. Your system is not within the limit. So as an auditor, as a system energy management person, I have to first look on, is there any penalty paid by the company or paid by the college? Okay. Now we study the capacitor panel. So they have a 100 kVA capacitor panel is available, or this is the and also they have a 50 kVA fixed capacitors is also available. So put together, they are having 150 kVA panel available in the industry itself. Apart from that, they are getting the 5.7 lakhs capacity. Now, what is the problem? Their capacitors is not properly working. The capacitors panels are not properly working. So therefore, we inspect the capacitor panel one by one. Okay. So we found that the first 20 kVA capacitor panel, it takes current in IR. R phase it takes current, but Y phase is not taking current. And B phase it takes current. Okay. And similarly, we measure all the parameters and found that only 79 kVA out of 100 kVA, only 79 kVA is connected in the line. The remaining are not turned on because of the problem in the closed loop system of the APFC. And similarly, for 50 kVA, it takes almost current, all the current, no problem about the fixed kVA. You can see with the help of this the readings, the system requires 40 kVA power. 40 kVA power. But you can see the system maintains 0.94 capacity. 0.94 is the capacity. That means some of the capacitors is not properly working. Some of the capacitors are worn out, and sometimes the capacitor panel is not sufficient to increase the power factor almost unity. So therefore, we give a recommendation to immediately nullify the problem, and you can get the penalty off. So this is the point. Normally we given to the system, right? So that is the things which is normally available, right? Then we have this is the second point, maximum demand controller. Normally, maximum demand controller, the name itself indicating that your sanctioned demand 350 kVA, 250 kVA will be fixed based on your connected load by the TNEB people or the target co people. When you exceed the demand, automatically you are penalized. So, for example, if the industry will get a penalty, again I go to the the previous slide, which will give you another clear-cut idea. You can see. You can see this is EDC. EDC is another penalty, excess demand charge. So this company got an excess demand. Why? They got a percentage, they got a sanction demand of only 200 kVA. But you can see the recorded demand is going to be higher, always higher. Okay, so because of that one, they are exceeding the demand what they are bought. So therefore, the penalty was imposed. Penalty was imposed double the time. So what is the kVA cost for HT Industries? I told you in the previous session. It is 350 rupees per kVA. Am I correct? So if you cross 1 kVA, if you cross 1 kVA from your permitted demand, it is doubled. 700 kVA is the penalty. 700 rupees is the penalty. Okay. So you can see in the EDC itself, it is going to be 5 lakh. In the DPF itself, it is going to be 5.7 lakhs. Put together, total loss, total penalty paid by the company is approximately 10 lakh rupees. Correct? So 10 lakh is the penalty paid by the company, not maintaining the power factor, exceeding the demand. Okay. So if you are maintaining the power factor, your EDC will also come down. Very important point. Why you are exceeding the power factor? Why you are exceeding the demand? You are not maintaining the power factor because power factor is going to be 0.82, 0.83. Average is going to be 0.83. So if you improve the power factor, I told you in the previous slide, automatically, if you improve the power factor, automatically my demand will get down. Earlier it's 900, now it is going to be 854. So I can escape from the penalty, or I can even connect more number of loads in the system. I'm not paying the penalty. So these are all advantages of the maintaining the power factor. So for not maintaining the power factor, we have APFC panels, and that should be properly and regularly tested. And similarly for recording the maximum demand, we have a maximum demand controller, and that should indicate that can be easily set at a fixed demand. For example, your connected load is going to be 250 kVA. You can set this maximum demand at 230 kVA. 230 kVA. When the load comes 230, it will give an alarm. That means you are very near to your demand. So immediately you can switch off the non-essential loads. By manually you can switch off. Sometimes MD controller available with the automatic also. So for that you have a two separate wiring. Essential wiring, non-essential wiring. Non-essential wiring will be given to the MD controller. It will wait for 2-3 minutes. When naturally the load comes, then automatically there is no problem. If the load is sustained or increased, it means the non-essential load will be cut by the MD controller. Okay, for quite a small period of the time. Then again it will start. Again that is by the manual or by automatic. So that is also available in the maximum demand controller to avoid the penalty. Okay, so any system, if you have a penalty, it is not within the limit. So paying the energy for our use is good, but paying the penalty is not good. Okay, so check your electricity bill for at least 1 year. Find out if any penalty you paid in your college or university. Right? So hotspots, I told you the equipment which is mainly used for measuring this is the IR thermometer. We will discuss the IR thermometer whenever we discuss the motor and things in the points. Okay. Now I think I completed the morning session. Is there any doubts? I can explain 2-3 minutes. Otherwise, we can go for lunch. We will come back by exactly 1:30. Madam?
Yes, sir. Thank you so much for your session, sir. So I'm sharing the feedback form link here on chat box as well as on WhatsApp group, so that everybody can fill the feedback form and submit it. And sir, any other questions from the participants?
I think Ashok sir gave a vibration analyzer, a question mark. No problem, sir. I will cover a vibration analyzer when we talk about the motor.
Okay, sir. So yes, we'll meet after lunch. I'll share the feedback form link here.
Madam, can I stop the sharing?
Yes, sir. Yes, sir. We can stop the sharing.
Okay, madam.
Anybody
I
has
will
any
join
doubts?
after. Okay.
Yes, sir.
Well, I will join after the lunch, madam. Okay.
Okay, sir. Sure. Thank you, sir.
Any question, you can please consolidate it and we will discuss after lunch.
Dr. Sivarasu, while we wait for everyone to join in, we can just have a short question answer round. So if any of the participants have any questions that they'd like to ask you, we can take those up now and we'll begin as soon as we have a good strength.
Okay, madam, I'm ready.
So participants, please, you can unmute yourselves or you can put your question in the chat box and they'll be picked up by Dr. Sivarasu.
So good afternoon, sir.
Good afternoon, sir.
Sir, is there any recent regulation has insisted that every company has to go for energy audit or this kind of audits at a frequent interval? Is there any regulation has insisted that?
Very good, sir. Sir, this is not applicable for all the industries, whereas
Okay,
there are some industries called designated consumers.
Okay, sir.
Designated consumers who comes under the cycle called PAT, perform, achieve, trade. So these industries having higher amount of energy consumption in terms of electricity, in terms of thermal and all those things that can be put together into a common unit called MTOE, million ton of oil equivalent. If their MTOE is higher than a prescribed value, they have to conduct an energy audit by accredited energy auditor, not certified energy auditor like me. There is an above us is AE, accredited energy auditor. They have to conduct energy audit and they have to submit the report to the Bureau of Energy Efficiency, in which they have to give some commitment to reduce their energy consumption in the next coming years.
Okay.
So this is for mandatory audits for the PAT consumers. Whereas for other consumers, other MSME or other industries, state government, especially Tamil Nadu government, now giving some subsidy to conduct energy audit. The scheme called PEACE, Promotion of Energy Auditing and Conservation of Energy. So under the scheme, any industry, any manufacturing industry and processing industry can do energy audit. For energy auditing, they, for example, if 10,000 rupees are charged for energy auditing, means 75% will be reimbursed as a subsidy. Number one.
Okay.
Number two, after conducting the energy auditing, if the recommendations are implemented by the company, then from the implementation, they will give 25% to the maximum of 10 lakh rupees will be reimbursed as a subsidy. This is the scheme which is already available in Tamil Nadu government. Now it is enhanced and it is now picking up in a very bigger way for MSME industries.
Okay. Very good information.
Thank you, sir. Thank you. Participants, any questions in the chat box? You can also use the chat box to ask questions or your doubts or any recommendations, any point to be additionally added. But also you can type in your chat box and let us know.
Yes, Dr. Sivarasu, I think if no one else has any questions, we can start the session.
Okay, madam. Okay, thank you.
Okay.
Okay, I think the screen is visible.
Yes, it will just be visible, I think, in a few seconds.
Okay. Now visible, ma?
Yes.
Visible, sir.
Okay, thank you. Welcome back to the afternoon session in day 2. In the morning session, we covered the basics of energy, in which we have an electrical system and a mechanical system, basic parameters and their units and their conversion factors. Then we touched upon the electrical system. Then we touched upon the mechanical system. Then we start with the power system. So in power system, we discuss about the electricity billing, especially for the Tamil Nadu consumers. As we know that we have a 2 type of consumers, LT and HT consumers, and basically the connected load or sanctioned demand will classify LT consumer and HT consumers, and tariff system, and what is the minimum tariff, maximum tariff, and what is the 2-part tariff system applicable for the HT consumers. What is the advantage and disadvantage of the HT consumers? Not directly, it is indirectly. Every system has its own advantage and disadvantage. Automatically, this should be taken into consideration. Okay. Now, in the afternoon session, we are going to discuss about the specific energy consumption, which is not touched in a very bigger way in the morning session. Then we move on to the lighting system, then electrical motor, then we followed by compressor, blower, and fans. Before going to talk about the system, I just want to give you why we have to go for an energy auditing or energy management system. Okay. Now let us have a system. I'm having a system. I don't know whether it is a mechanical system or an electrical system. Doesn't matter. It is run for 1 hour. Now for 1 hour, it takes 100 units of electricity and produces 100 pieces of output. Right. So now the specific energy consumption is 100 by 100 equal to 1. For producing 1 piece of output, 1 unit of electricity is consumed. This is the specific energy consumption. Now the system is running for 1 hour. Okay. Now I did some modification. I did some energy conservation efforts in the system and make the same 1 hour. Now the system will take same 100 unit, but rather producing 100 unit, now it is producing 110 unit, 10 pieces higher than the previous one. Now this is called energy conservation. Right? Second, if I make the same energy conservation a different way, I run the same system for 1 hour. Now it produces 100 pieces for 1 hour, but it takes 90 units. So in both the cases, it is advantageous for the people who implemented this energy conservation measure. Am I correct? Earlier, it is 1 piece, 1 unit for 1 pieces. Now it is reduced below 1. Am I correct? Now this is called energy auditing, outcome of the energy auditing. Normally, the energy auditors will propose same energy with increased productivity or same production with reduced energy. But as of now, the trend is completely changed. Especially our team is keep on looking for the third eye. Same 1 hour, 90 units, 110 pieces. So that will further reduces my specific energy consumption. This is called the true energy audit, which will give an increase in productivity with reduced energy consumption. This is what normally we require. Okay. Now, with the help of a simple example, a case study, I will explain you the specific energy consumption, how it can be linked to the production, and how it can be very important for linking the specific energy consumption with production. What are the data we can get from the specific energy consumption and the production, and also linking these two. A simple single line diagram will show you the starting point to the end point of a tea industry. I don't know whether how many people visited the tea industry, which is available in Nilgiri, nearby Nilgiri districts. We conducted more than 30 private and government tea factories. And the section of the tea manufacturing process is represented in a single line diagram starting from withering. Withering is a process which will reduce the moisture content of the leaf. So for that, we require both electrical energy as well as thermal energy. And similarly, starting from withering to the end of merged tea, output is merged tea. So in every stages, we may have electrical, we may have thermal, we may have both. So 2 type of energy carriers are used. One is electricity and another one is thermal energy. 99% of tea industries in Nilgiri districts are using wood as a thermal energy. But some industries are moving away from wood. They are using coal, they are using even electrical heater also. It is mainly used for drying the tea. So it is not producing steam, so therefore it is only for producing the hot air. Okay, but 99% are wood industries, wood-based industries. Now this data will give you a clear-cut idea of the specific energy consumption. Before that, I will explain you the left column one by one. apart from the serial number and month, 1 year consumption, how much amount of tea produced, output manufacturing tea produced in terms of tonnage. So 82.71 tonnage, the November 19th means 82,710 kg of tea produced from the tea factory on that particular month. So for that production, 1 minute, for that production, they consumed nearly 141.41 tons of wood, and their cost equivalent, the equivalent of cost is going to be 7 lakh rupees. Nearly 2,500 to 3,500. Now it is increased to 4,500 per tonnage of wood, because wood is not available in Nilgiri districts. It is come from the nearby district. Of course, they are also available, but most of the wood come from the plain station. They are using electricity consumption. Electricity consumption is going to be approximately 51,000, and the cost is going to be 5.24. The total cost put together 7 lakh plus 5.24. The total cost is going to be like this, right? Now the share of firewood is going to be 57%, and share of electricity is going to be 42% for the month of November. But put together average 52%. Higher is the electricity, almost equal, almost 50%. Electrical 50%, and thermal is going to be almost 50%. Now, the very important point is the last column, rupees per kg, output, how much amount of output produced and what is the cost involved in this one. So it is involved 12.28 lakh rupees for producing 82.71 tons. So for 1 ton of tea or 1 kg of tea, the cost of energy is going to be 14.85 rupees for the month of November. Okay. Now you can take. Now you can easily understand why it is very important and why it is linked to the production. Okay. Now the specific energy consumption is different. Now I am linking the energy consumption with the production, and I am getting a new term called rupees per kg or rupees per tonnage or whatever may be for the system. Okay. Now it is not same. It should be same for all the industries, but for the tea industries it is not same. You can see. For the month of November 14, it's a November 19, it's 14.85 or approximately 15 rupees. Now 17, 20, 16, 17, 15, 16, even 22, 24 also, 24.68, approximately 25 rupees. And again, it is come down. The average is going to be 17.9. Now, why this difference? It should be always same. Am I correct? It should be always same. If the system is good, if it is properly maintained, properly handled, properly operated, then your specific energy consumption linked with the production should be always same. But in tea industries, it is not same. And we are asked to find out what is the reason for that one. This is the assignment given to us by the Incoasm Tea Factory Managing Director. At the time, Managing Director. Now he is a collector of Tirupur. Okay. So many players came into this, and we got this order. And we represented this point in a very clear way. And because of that one, we got 14 audits for different Incoasm tea industries. Now, what is the reason why the specific energy consumption is not same? It's not unique, and it is keep on varying from 25 to a minimum of what is the value? What is the lowest value? Lowest value is going to be 14.85. Almost 10 rupees, 11 rupees is the higher value. What is the reason? The reason is very different and very bigger list also. I will show you. This is the reason. Maybe the price of the wood is keep on varying. Every month the wood cost is going to be keep on variation. Sometimes it is higher, sometimes it is going to be lower. Sometimes it is not available. So therefore, when the wood is not available, then automatically they can go for another type of additional alternate fuels like briquettes. So briquette cost is going to be slightly higher. So these are all some of the reasons. Second important reason: higher wood consumption in winter. As you know, that tea industries will be always available in the hill stations, especially for the Ooty and Nilgiri districts. Now the temperature is going to be lesser, so lesser. Even sometimes it is going to be minus. So at that time, the amount of air, hot air required air can be produced with a higher wood consumption. So this is the reason. Second one is quality of the tea leaf. So normally UPASI norms, United Planters Association Federation, UPASI norms give how you plug the tea leaves. It should be always 2 leaves on 1 bundle. But mostly it is not like that. Normally they will randomly pick the leaves. So because of the quality of the leaf, because of the moisture content of the leaf, then automatically higher wood consumption is required for the withering application and similarly for the grinding applications. Then controlled withering process of the withering section is going to be not controlled. It is going to be uncontrolled in nature. Sometimes it is doing in the morning, sometimes in the afternoon, sometimes in the night. So automatically, if you do the night time, moisture content is going to be very higher. So that will also reflect in the leaf. So again, this will be taken in a higher value. And last one is going to be fixed cost and electricity during the lean period. As tea industries is not running with 100% capacity for all the year. There is a lean period always available. So I think this is the lean period. Now the temperature is going to be very low. So normally the tea factories, tea industries are not running. They will only having some stock that should be grinded as a tea. I mean most of the tree plants now under maintenance. So because of that one, the capacity of the plant is reduced. The loading factor of the plant will be reduced. But even though if it is a loading factor reduced, you have to pay the fixed cost. Right? That already I told you in the morning. So fixed cost will be killing sometimes. So it is going to be very higher, or it contributes more amount of money, even though if you are not taking the production or lesser production. So these are all some of the reasons. And we found out some of the solutions given to the industries, and moreover, they will get some good benefit out of the things. So if you reduce one rupee from the present value, then it will be very great boost for the industry. From the specific energy consumption point of view. So rather looking for the energy, if you're looking for the specific energy, linking the energy with the production, then it will give additional dimension, a new dimension in the energy auditing and energy management system. Okay. Now the thermography, which is not seen in the morning session, we have only one slide, but I will show different slides for the thermography. You can see it's a new tool. As Mr. Ashok sir told that he want to have a vibration testing also, but I just want to tell you vibration and thermography is not a tool for energy management and energy auditing. Rather, it is a tool for condition monitoring of the device or condition monitoring of the system. Okay, when you are properly monitoring your system, then automatically the failure rate on the system is going to be reduced. That itself is a conservation. Okay, so this is a new topic. New device, of course, it's not new, it is already available, but now it is predominantly used in most of the industries, most of the auditors in a very bigger way to find out the hotspot of the on the system. Okay. Even your normal mobile phone can be converted into a thermography based camera by fitting an additional component like this, which is available in Amazon itself. But only thing is accuracy and that will be a problem. Now it is normally always almost all the places we are using. We are using this for airport, railway stations, then volcano eruptions, solar photovoltaic panel monitoring system, wind monitoring system, healthcare industries, safety, surveillance, building envelope inspection. So many. It is basically working under the principle of emissivity. How much of light it is emitted, heat emitted from the particular surface when it is penetrating with the air. There is a delta T again, the difference between the emitted object with the ambient temperature. Normally, how we are going to define higher temperature means we will always compare with one standard value. The standard value will be an ambient temperature. So ambient temperature can be measured first initially, then we have to measure on the object. When the difference between delta T, difference between these two is higher, and we have a classification based on the NETA, National Electrical Testing Association. We have some classification. And we have some priority also 4, 3, 2, 1. Okay. Now, if it is a 4, falls on the 4 means automatically the discrepancy delta T is going to be between 10 to 25 degrees. So therefore, there won't be any problem as of now. When the severity is going to be 3, then automatically the difference is going to be 25 to 40 degrees. Then automatically the component failure is going to be probably, unless corrected, you have to correct it. Then if it is 2 means it is going to be more vulnerable. Then 1 is going to be immediately you have to attend the problem and stop the system, and you have to attend the problem. So this is the rule based normally, but sometimes thumb rule is also available to find out. Okay, thumb rule is also available. That is normally taken between ambient temperature to the object temperature is going to be more than 30 degrees. Then automatically you have to take some action. So that's called thumb rule based or knowledge based. Okay, so we have different associations are available, and we have their own priority levels. Okay. So these are all some of the photographs which we taken at the time of auditing. Normal eye cannot able to detect the corrosion, and because of the corrosion, the temperature is going to be very high. That can't able to see in the normal light. Whereas the thermal eye will give a clear time. You can see even in the motor starter, because of rust formation in the cable or on the wire, which will have a higher temperature, and because of that one, frequent tripping is going to be taken place. You can see the cable joint will have higher temperature. Insulation completely weakened, completely melted because of that one higher temperature. Even in compressor, top of the compressor, you will have a higher hot air will come out. So that can be used for waste heat recovery. That we can see in the compressor area. In fuse link, you have to check and find out whether the fuse link is higher. Any corrosion or loose connection. Even in a control panel, because of the loose connection, the higher temperature is going to be always available, even though it is a less voltage, less current. This is the furnace outer body. You can see the temperature rise is going to be very higher. Even though it's a furnace, so therefore normally it is high. But we can prevent, we can reduce this value by applying some energy conservation techniques. If it is reduced to even 100 degree, then the 100 degree will be always inside the crucible, inside the furnace. So that will be mainly useful to melt the metal. So therefore, less amount of energy can be used for melting the same metal, same quantity of the metal. So therefore, this is also very important for. Then
Excuse me, ma'am. Ma'am, we can't hear anything.
Good afternoon to everyone. எனக்கே சொல்லு என்னது? இல்லையே நான் பேசுறது கேட்கல. நீ பேசுறது கேக்குதா?
Hello, madam.
Yes, Dr. Sivarasu.
Yes, madam. I joined. Sorry.
All right. Okay.
1 minute. Okay, madam, is visible?
Yes.
Hello.
Yes, sir.
Okay. Sorry, there was a problem in my system, maybe network, so that it was stopped. So we discussed the thermography analysis of the previous slides. We discussed about the thermography analysis, how it is important, why we have to take non-contact type measurements, how it will be useful for getting the parts of a given system, and also it will be very useful for a better tool for condition monitoring of any equipment or system. Now the next topic is a lighting system. We have to go very fast, and within 3:15 I have to complete lighting as well as electrical motor. Now lighting is a very neglected area. We have lighting all around the world. Without lighting, we can't able to imagine our life. Something similar to our electrical lighting system. We haven't keep on changing with respect to the time to time. The energy efficiency is keep on improving, starting from ordinary incandescent lamp. Now it is going to be LED based. Even induction lights are coming into picture. So these are all the table shows that the type of lights and what is the wattage of the particular lamp. Then how to calculate the power consumption and similarly energy consumption, as already we discussed the same point in the energy calculation level. Now light intensity can be measured with the help of an instrument called Lux Meter, and that is simple. Lux is an illumination per unit area. So which area we are going to consider, that area taken into account, and that should be per unit area, 1 meter square or one square feet or whatever it may be. So for that particular area, how much amount of illumination level is available? Artificial lighting, not for the natural lighting. Natural lighting is different from the artificial lighting. We are talking about the artificial lighting, artificial lamps. Now the Lux level should be carried out by calculation. Measurement will be taken care by the Lux meter. Normally, it should be measured at 0.8 meter from the ground level or floor level. That's a case, but it is different. Normally what we are insisting that whenever in which place you are measuring the light, that should be equal to the operating place, so place of the operation. So that should be very comparatively one. Then we have a different type of lighting system, starting from incandescent lamp, now conventional lamp of fluorescent tube light. One of the things is fluorescent tube lights are scattered source, and whereas the LEDs is a point source. It is not advisable to go for energy conservation with an LED. I accept that energy conservation can be possible if we go for conventional lighting to LED, but keep remember that what type of area you're going to change from conventional lighting to the LED lighting system. Now, this figure will give you a simple comparison of the conventional lighting system with LED. The life of the LED lamp is very longer, and similarly, the illumination level output of the LED is also higher. But keep remember that it's a point source. Somehow we can't able to conserve the energy by neglecting our eye pain. So it is very important where you are going to change your lights and what is the opportunity to change the energy efficiency whenever you change the lights from the conventional to LED. But rather, instead of going for changing the LED light FTL to LED, rather you can optimize the lighting system, the way in which you are operating the lighting system, lighting circuit. So that will give you more energy conservation. For example, if you use more day lighting by using the polycarbonate sheet on the top of the floor, so that will invite more amount of natural light inside the factory during the daytime. Similarly, the buildings, as you know, that green building applications are majorly focusing about higher amount of lighting system, natural lighting system coming into the building during the daytime. So artificial lighting system can be reduced during the daytime. Similarly, you can use a proper reflecting stickers, reflectors to give more amount of light into the particular spot where you are working or where the people is working. And you can regularly clean the lamps, regularly clean the reflectors, so that will give you enhance your visibility. And similarly, occupation sensor-based lighting system. When the people are available, then the light will be on. And based on the people, again, the intensity of the light can be increased or decreased. So that can be also used. So most of the time, it will be available in a toilet and similarly for runways of airports. Then applied voltage is also very important for the lighting system is concerned, because higher amount of voltage will also lead to failure as well as more energy conservation, more energy consumed. So rather applying a constant voltage and regulated voltage to the lighting system is very, very recommended. Normally, we recommend. Normally, when you see any industry or even colleges, we have a separate fader for lighting system. Lighting circuit completely disconnected or detached from the power circuit. If any surges in the power circuit, that should not reflect in the lighting circuit. So that is why it will be separate. But rather, we recommend to have a separate servo stabilizer for the lighting system as an input parameter. Applying a constant voltage to the lighting system will reduce the lighting failure. And if you set the voltage at a common level, then also a small amount of energy can be saved. That is another advantage. In Coimbatore, you know, there's a very famous college. They are installing 75 kVA oil-cooled servo stabilizer for lighting and fan system. For the past 6 years, they do not have any failures. So that itself is a very good conservation. Okay. What are the best operating practices? BOP means the best operating practices for the lighting. So you need to properly maintain your inventory of the light and provide separate energy meter for the lighting system. That's very important because the light load is very higher, especially for the IT building, malls, shopping complex, where the lighting load is predominant. So therefore, you can have a separate feeder, and that feeder should be fitted with the energy meter, digital energy meter, to monitor how much amount of energy is consumed only for lighting system. Similarly, for monitoring energy bill every month and what is the maximum average power consumed by the system, and also you have a demand controller for the maximum lighting system. Then you need a proper mechanism to turn on and turn off the lighting system, either by a manual or operating. And similarly, go for an lighting energy savers, energy efficient lighting system. Provide a separate APFC, separate servo stabilizer, separate transformer, or even transformer with a servo stabilizer. It's also called as a lighting transformer. So for your lighting circuit, that will reduce your lighting system. Right? Now, measurement of the lighting is very different. Okay, so I will show you the measurement of the lighting system is for a particular place. It depends on the factors. Okay. I will show you one report where what is visible. This report is visible. Bird file. Hello?
Visible, sir.
Okay.
Visible, sir.
Okay. Now this is the lighting measurement we taken in an industry. It's a very vast industry in Chennai, and we are doing these practices for even colleges also, because environmental audit also talks about the lighting audit, the lighting comfortness. Lighting comfortness is a very important parameter for any other things, because when the lighting is not adequate, then automatically people will complain, productivity will come down, even accidents may happen. So therefore, we conducted a separate lighting comfortness audit for each and every room, and based on the room activity, we are giving a recommendation. So I just give a simple example of a table which shows that where we are taking the reading, and what is the area of the particular room, and what is the height in which the light was mounted. And based on these two parameters, what is the area of the room, and based on the mounting height, we will calculate how many readings to be taken in that particular room. Okay, so for nearly 10 by 10 room, or 10 by 16 room, or 10 by 11 room, or even more capacity rooms, if the only one measurement or two measurement or three measurement is not enough, there is a standards as per the BE. You have to take this much amount of measurements in a particular area. So based on that, we take a measurement, a 9 measurement, 12 measurement, 25 measurement, 36 measurement, and depends on that. So in that, we calculate what is the minimum value, what is the maximum value, and what is the average value. Now we take this reading with the help of a Lux Meter on the particular floor or a particular area. Now this can be compared with the standard. So there are two standards are available in India. One is NBC, National Building Code Standard. Another one is ISRE, Indian Society for Refrigeration, Air Conditioning, Heating and Air Conditioning standards. But most probably IT building, ECBC, IGBCs are using NBC standard, National Building Code Standard. Okay, I will show you the National Building Code standards after this presentation. So that will describe you, depends on the activity on the particular area, what should be the minimum light, what should be the average light, and what should be the maximum light to be provided on that particular area. Okay. For example, if it is a commerce, then the minimum is going to be 300, maximum is going to be 750, and average is 500. Now we will examine whether the minimum and maximum, so minimum and average falls in this category. If it is falls in this category, we will give an indicator that it is good. So there is no problem. Even though it is going to be very higher, sometimes if it is more than 750, we will indicate higher value. Okay. Now if it is fall within this value, then automatically we will get the indicator is good. Sometimes we will give action. Action means this is the minimum value and average value is lesser than the specified minimum value. See, you can see this discussion room 1, the minimum value is 48, average value is going to be 238, but the minimum required is 300. So both the value, of course, the higher value is going to be correct, but both the average value and minimum value is lesser than the NBC standard. So therefore, we are giving indicator as an action. That means you need to increase the lighting illumination level, either by increase the number of lights or increase the wattage of the light in the present system. So that we are giving indication, action. Sometimes we will give review. That means it is very closer. Average value is going to be very closer. You can see the minimum value is going to be lesser, but average value is going to be very close. 282, it is going to be 300. So review means you can take not immediately, but at later stages, you have to improve the lighting system. So that is the point normally we will give in terms of lighting audit. So not only the measurement, we also give a survey. So in this report, we also conducted a survey like this. Okay. Now, based on the available persons in the factory or office, we will take at least either a 10% or 5% people, and we will give some questionnaire, and based on the questionnaire, we will come to some conclusion. We will ask some questions about the lighting system, and we found that. See, you can see this is the in the observation. Okay. Yeah. We have 65 samples, 65 people we take the survey, and that too all from executive level, supervisor level, even operator level. So it's a mixture of all, and we refer two outcomes. One is lighting is good. Nearly 80% of the people told that lighting is good, whereas 21% of the people told that lighting to be improved, not good, but it's to be improved. So we may have 3 different categories: good, to be improved, or not bad, or the third category. But what we are having is 3: good, satisfactory, to be improved. Good is going to be 80% in this category, 21% is going to be improved. And also they will tell where the improvement to be made, either in the work area or in the common area like parkway, walkway, canteen, toilet, bathrooms, cycle stand, two-wheeler stand. That also you have to record, and it should be matched with your reading where you have to take it. Suppose if some people are telling that canteen area is going to be with lesser illumination level, then if you take the lux level in the canteen, that should be always lesser. Otherwise, the people will lie or your reading will be wrong. So it should be properly coincide with these two values, right? So that's all about the lighting system, and we will come to the point of the next topic, electrical motor. Very interesting topic, and most of the people will know about the electrical motor. 90, even more than 90% of the motor in the industries are split electrical motor, and of course, application of the motor is n numbers. N we can have an n number of applications we use this motor. So it's an electromechanical device taking the input of AC, taking the input of electrical energy and giving the mechanical output. Most of the motors available in the industries are AC motor. Sometimes DC motor is also available. If you have a DC motor, then automatically you have power converter is required. So these are all the various components involved, and you may tell to the students that these are the important components which are very whenever you go for an auditing. Now the first one is going to be an outer body, second one main frame, then we have an end covers, then we have a rotating portion, stator, rotor, and finally you can have a cooling system, cooling fan. So that cooling fan is going to be keep on rotating when the rotating component when the rotating component is rotating. So automatically the heat generated inside will be evacuated to the backside fins. Now the output mechanical power and electrical is an input power. So keep remember that motor efficiency can be determined by output divided by, right? Now the nameplate of any motor will always represent the output power, not the input power. Keep remember, 99% of the people will know that. If the nameplate says that it's going to be 3.7 kilowatt 5 HP, that means it's an output power, not the input power. Okay. Now, what is the input power? Input power equal to output divided by efficiency at full load operation. Assuming that the motor is at full load, then the output power 3.7 kilowatt divided by 95% efficiency or 90% efficiency or 85% efficiency, that will give you a full load input power. When the motor runs at full load, then this must be the power taken by the motor. Okay. Now, in this case, input power is at 40 kilowatt, output power is at 36. So, therefore, the efficiency of the motor is 90%. Okay. That means 4 kilowatt is the self-consumption of the motor. The very important point is 4 kilowatt goes where? The 4 kilowatt taken by the motor. It takes, it eats actually. So, 4 kilowatt multiplied by 10 hours is the 40 unit. So, when you run this motor, the self-consumption of the motor is 40 units, 40 kilowatt hour. So that's why we are insisting to improve the efficiency of the motor, and so that the input power is get reduced. Right? Now the motor efficiency is one of the important factors. The second important factor is the loading percentage of the motor. Always we believe that the motor will operate at full load condition. It is not like that. It is not like that. Okay. So basically, it may be at 25%, 50%, 75%, at 100%. Sometimes it is more than 100% also. Okay. So we have some certain limitations available in the motor. So therefore, the loading percentage of the motor should be properly calculated. And this is the formula for calculating the loading percentage. Loading percentage easily calculated. Input power drawn by the motor at existing load condition. Okay. We don't know what is the load condition, but so that can be taken as a reference. So at that reference, what is the input power? How to calculate input power? We can't able to calculate, we need to measure. Okay, some parameters we can calculate, some parameter we have to measure. Okay, so that is the case in the in energy auditing field and energy management field. Okay, so all the data we can't able to calculate, all the data we can't able to assume, and similarly all the data we can't able to measure. Something we have to measure, something we have to calculate, something we have to do both. Okay. Now the input power can be measured by with the help of a power analyzer or load manager, and by what is the input power. Now divided by nameplate full load kilowatt rating divided by nameplate full load efficiency. So that will give you my percentage loading. Okay. Nameplate full load efficiency. The simple example is given here. So for example, I have a 11 kilowatt motor which is equal to 15 HP. Now efficiency of the motor is 88%. Measured input with the help of a power analyzer is 5.62 kilowatt. Now input power, what is the input power? If it is under full load condition, if it runs at full load condition, 11 kilowatt is the output power divided by 0.88 is by input. So 12.5 at full load. If you operate the motor at full load condition, then it's 12.5 kilowatt should be taken. But now it is taking only 5.62. Now you can take the ratio. That's called lesson loading. So what is taken now? What is actual? What is the design at full load? So 5.62 divided by 12.5, which is equal into 100. That's equal to approximately 45%. So now this motor is operating at 45%. That means this motor is undersized. Am I correct? This is undersized because it is designed for 12.5 kilowatt full load condition, but you are operating at 45%. Keep remember this loading may be constant sometimes it is varying. Okay. Now the motor not only deliver the mechanical power, sometimes not sometimes 99.999% it drives the load. The load sometimes is constant, sometimes it is varying, sometimes it's going to be lower, sometimes it's going to be higher, sometimes it's going to be constant. So you can't able to say that this is an underloaded motor for this condition. Sometimes after 1 hour, after 2 hours, the load may increase to 75%. Same motor. So you need not tell that this is an undersized motor. You can replace with that instead of 11 kilowatt motor, you can replace with a 7.5 kilowatt motor or 5.5 kilowatt motor. So that will be energy efficient. This is not correct. Actually, you have to see what is the present loading condition and similarly what type of load it is carrying for entire 24 hours or even for a complete cycle. Then only you have to come to a conclusion that whether this motor is underloaded or properly designed. Okay, so any motor properly inventory card should be maintained. 99% of the industries are not doing this activity. Of course, slowly now the industries, of course, the top industries are doing this activity. Regularly, they have a maintenance card. Regularly, they have a history card. Regularly, they are maintaining the lubrication level, grease level, temperature level, belt tension level. Everything they are taking the readings. But none of the small industries, medium industries are not taking. Now we are educating these industries to do this activity because that will be a very great database for the company. Okay. Now you can see the type of motor, where it is connected, whether it is connected to pump or fan or what process it is going to be used, what the frame size, what the make, when it is manufactured, even you can tell after manufacturing when it is put in service in your company. Okay, even though it is manufactured in 2008, you may buy the motor in 2009 and you can fit the motor in 2010. Okay, so that also you can take into account. Then what is the nameplate reading? Nameplate value of the HP, voltage, current, efficiency, and speed. Then how many times it is rewinded? 1 time, 0 time, 2nd time, 3rd time. Then what is the approximate operating hour in a day? Okay. Now so many problems are comes into picture. Similarly, so many solutions are also available in the motor. Okay, the very important problem is underloading. So I told you now, most of the time people will take that it's going to be underloading condition because the factor of safety is going to be very higher when you select the motor, and the OEM also insists to go for a higher motor for a particular application. So therefore understressing. So understressing means automatic increase in losses, motor efficiency is going to be reduced, power factor is also reduced. So the main important solution is you can optimize the motor at proper loading condition. Suppose if the loading is going to be lesser than 40%, you can run the motor in star mode of operation instead of delta. Keep remember, if it is a constant load application, this will work. For variable load application, it will not work. Okay, there are separate star, delta, star starters are available. If the motor is always 40% load condition, then you can go for this type of application. Otherwise, it will not benefit you. Okay. Now, similarly, you can also place proper sizing of capacitors at the load end, at the motor end. That will reduce not reduce the motor power, but reduce the current flowing to the cable from the supply point to the motor. That will be reduced. Keep remember, connecting the capacitor at the load end will not reduce your load power. Rather, it will reduce the distribution loss. The cable carrying the power from distribution point to the load point, that will be reduced. That is why we are insisting to connect the capacitor. That will reduce your I squared R loss or distribution loss or cable loss. Also, it will reduce the voltage drop. That will also reduce my kVA demand. Okay. Now you can see this is the simple example where a motor, we don't know the capacity of the motor. Now the motor will take 100 ampere current. So the active out of 100 ampere current, active current is going to be 80 ampere, 60 ampere is going to be the reactive current. So it is a cube root, square root of square of this two value and take the root. So it is not an arithmetic sum. It is going to be an 80 plus 60 is going to be 160, not 140, not the value. It's not an arithmetic sum. It's going to be a take the square root and take the root. Okay. Now the 60 ampere is the reactive current supplied by the system to the motor to establish the magnetic field, right? Now, instead of taking the 60 ampere directly from the supply, you can have a separate capacitor. Okay, you can have a separate capacitor. Now, this capacitor will take or will supply the reactive power current of 60 ampere, the required reactive power. Okay. Now, the motor will take only 80 ampere. So now you can see the cable from this point to this point. Earlier carry 100 ampere. Now it is 80 ampere. Now 20 ampere is reduced. So what is the energy saved? I squared into R into H. Am I correct? I squared current whole square multiplied by the resistance offered by the cable multiplied by how much operator time, that will be the energy. So I squared R is the power multiplied by the time is the energy saved in the cable because of the 20 ampere reduction in the system. Okay. There are thumb rules are available to connect the capacitors, either a minimum value or based on the measurement you can connect. So my recommendation, you can connect the capacitor at the load end by taking the measurement, not by the thumb rule. Then we have two type of losses. What is a fixed loss and the one is a variable loss. Then you know that variable loss will be purely depends on the resistance of the stator and resistance of the rotor. Sometimes it's a small amount of stay loss. Magnetic loss is also called as a fixed loss. Fixed loss is purely depends on the speed as well as the frequency of the operating system. Now, what are the instruments used for measuring the performance of the electrical motor? Normally, we use a tachometer, either sometimes non-contact type or contact type, digital or sometimes analog type of tachometer. Now, tachometer was now replaced with stroboscope. So then we are using tachometer. Now also some people are using tachometers, but now it is replaced by stroboscope. So stroboscope, even if you have an motor guard, you can't able to open the guard and you can directly measure if you know if you're able to see the rotating parts. So with the help of a stroboscope, you can take. Then alignment and vibration meter. I will tell you this part in an elaborate way. 2-3 important points are available. This is the meter which is used for measuring the vibration as well as misalignment. Vibration and misalignment of the system, and that will be also a very good condition monitoring tool. Then heat developed can be in the motor can be measured with the help of an IR thermography or IR thermal gun. Then the electrical power can be measured with the help of an air quality analyzer or load manager. This is the history card which already we saw that. And this is the database you have to create in an industry based on several parameters, based on the age. If more than 16 age, how many motors are available? Below 2 years, how many motors are available? Based on the classification, whether IE1, IE2, international efficiency 1, 2, 3, 4, 5. So 1, 2, 3, 4, even 5 is also available now. So how many motors are available? So based on the rewinding status, how many motors are available? Based on the loading factor, how many motors? Based on the operating hours, how many motors? So this will be given a clear idea. And based on that, you have to fix the problems. Then normally the causes for the failure of the motor is heat, dirt, moisture, vibration, power failure, not proper having proper ground. Similarly, loading is not proper. Temperature evacuation, heat evacuation is not proper. So these are all the major issues normally the motor will experience because the failure will be available. So what are the best operating practices? You can use proper spacing of the motor. Always you can prefer higher efficiency motor. Motor maintenance should be very proper and rewinding should be always within only one time. It is recommended always only one time rewinded. More than 2 times it is not recommended. As you know, if you rewind the motor, automatically efficiency will get lost. Power factor should be also maintained at an optimal level, and motor starting methods and similarly on and off method should be very proper. And you can use either VFD or soft starter. Suppose if you have a variable loads. Winding should be properly redesigned if it is rewinded. Only one time rewinding is recommended, but some industries are even doing more than 10 times. Whenever if you do the rewinding, automatically at least a minimum of 3 to 5% efficiency will be reduced. Even 1% reduction that will have a very huge impact on the input power. So that will be not advisable. So rewinding will affect your motor efficiency, design of the winding, material, performance of the motor, insulation of the motor, and everything. So therefore, you do very practical, very approachable, very correct rewinding procedure. Check the motor before and after the rewinding and assure that the efficiency loss is going to be very, very minimal. And make a marking on the motor such that it is 1 time rewinded, 2 time rewinded, 3 time rewinded, and all those things. And insist your management not go for more than 2 times rewinded. Then your maintenance plan should be properly improved by inspecting the motor, by the belt tension, heat, vibration, all those things should be properly or regularly recorded, regularly measured and recorded, and that should be checked with your design value. If any deviation in the design value, automatically you can get over this with your OEM. Then what are the energy saving potentials are available? You can go for an energy efficient motor, optimal transmission efficiency, speed control of the motor. When the load is going to be lesser, then we can go for a lesser speed connection. So when the speed is lesser, automatically friction losses will be get reduced. So your input power will be lesser. So that will have a very good impact. That's why we are using VFD drives or change in pulleys. Then power factor correction of the capacitors. This is not directly concerned with your motor power, rather cable power. Reduce underloading motor. You can properly design the motor. Otherwise, it will be a higher capacity motor will lead to higher losses, input losses, rewinding and proper maintenance. So normally it is recommended to go for an energy efficiency motor. Now the standard is IE1, IE2, IE3, IE4 efficiency motors. You can see IE1 is going to be standard efficiency motor, IE2 is going to be higher efficiency motor, 3, 4 is the premium and super premium efficiency. Only thing is the cost is going to be slightly increased. So when you take the life cycle cost overall for 10 years, if the motor is running, and how much is the amount of energy it consumed, what is the cost you bear for the energy, and what is the cost you bear for the motor purchasing? Normally, the purchase cost is going to be only 5%. Your 95% is your energy cost. So don't look at the initial cost. You can look at the running cost. So that is why always people will tell that who is clever? Who is clever? A person who is selling the car or a person who is selling the petrol? Who is clever? So I left this answer to the participants. Okay. So in that way, you can just look at the energy cost for the entire life cycle. That can be taken into account. Don't take the initial cost. Initial cost is going to be slightly higher, but you can get the good payback within a short-term plan. In speed control of the motor, as you know that speed of the motor is directly proportional to the to the flow rate of the system, and similarly, it is that speed is square of the speed will be directly proportional to the T, and similarly the power is going to be Q. It's called affinity law. We will discuss later. Okay. So a simple example, a simple case study shows that a 7.5 kilowatt motor running for 20 hours without any speed, which is connected in the cooling tower. Okay, so the cooling tower flow is not changed because of the temperature, because of the flow, or because of the process. It is not changed. It is keep on in the same operation. So therefore, the company installed a VFD, a closed loop VFD, by checking the temperature of the atmosphere and checking the process. So based on that, the flow rate of the pump will be reduced. So when the flow rate is going to be reduced, it means automatically the motor load will be reduced. So earlier 20 hours running motor will be now running at 17 hours. So because of that one, approximately 11,000 units will be saved in an industry. Similarly, for oversized motor, if you go for a very correct size motor, you will get a 3% or even 4% saving based on your loading percentage. In almost starter, you can have a direct starter and stop starters. Practices motor. Okay. So that's all about the motor, and we have a 10 minutes break. Can we take 10 minutes break? We'll come back with another set of some motor information. Then we will go for compressor and pumps. My name is good.
Sure, sir. We'll take a break.
Now the time is 11 o'clock. Sorry, 3 o'clock. I will join by 3:10.
Sure, sir.
ஹலோ வணக்கம் சிவராஜுங்க. வணக்கம் மேடம், சொல்லுங்க மேடம். ஒரு பிரசன்டேஷன் இருந்துங்க மேடம், எடுக்க முடியலைங்க. சொல்லுங்க மேடம். இல்ல பிரேக் தாங்க மேடம், ஒரு 5 நிமிஷம் பிரேக் இருக்குது மேடம். சொல்லுங்க மேடம். சரிங்க. ஆமா ஆமா ஆமாங்க, பேசியிருந்தாரு மேடம். ஆமா ஆமாங்க ஆமாங்க. Madam, is it clear?
Yes, sir. Please go ahead.
Thank you. Okay. Now we are in the last session. We are going to discuss about the pumps as well as air compressors. Of course, both almost are same. Air compressors, pump, air blowers, and fans are only on the same category or same family. Only thing is the specific power consumption is different. Okay, when the specific power consumption is going to be lesser, then it is going to be blower. It's going to be slightly higher. It's going to be a compressor, right? And similarly, if it's going more than that one, automatically it comes under the category of pumps. Let me first discuss about the pumps because normally we are using the pump for our water pumping applications. There are basically two type of pumps. One is a dynamic one or centrifugal pump. Mostly 90% of the systems we are having centrifugal pumps, and the second one is a fast displacement pump. Only thing is the way in which it is operating, and similarly the arrangement for manufacturing this will be slightly different. Okay. Now in pump we have only three important parameters. As like as electrical we have only three parameters: flow, head, power. That's flow is going to be equal to current, head is directly proportional is equal to pressure, and electrical power. As you know that we are talking about the pump, so therefore pump will not operate separately. We need a motor. So it's a system. So it's a combination of pump as well as electrical motor. Okay. Now this figure will give a clear-cut idea about the head or the pressure required to pull or to push the liquid from one place to another place, right? Now we have a water sump, we have an overhead tank, so we need to fill the overhead tank with the help of the water which is available in the sump with the help of a pump, right? Normally we have two type of heads will be always available. One is a delivery head, another one is a suction head, HD, and another one is HS. Okay, now you can see from the center of the pump to the above is called as a delivery head. So on that point onwards, it is delivery. So below it's called as a suction head. So we need a proper pressure to take the water from the sump to the to be filled in the overhead tank. Even though if it is a flow is available, when the pressure is not adequate, then the water will not come out. Okay, so we need a very proper mechanism, very proper head or pressure is required. So definitely that pressure will move your liquid. That's induce your flow. That's a simple theory of your electrical science, where if you need voltage, if you have voltage, then voltage will be converted into current. So current can be flowing from higher potential to the lower potential. Same thing is going to be applicable. You have a suction and you have a delivery. So in between that, there is a pressure difference between these 2 points will be created by the centrifugal action. Okay. Now you need a power to create the centrifugal action so that the pressure difference is created. So because of that one, the water or liquid will be flowing from this point to that. Okay. Now this is the formula which are mainly used for calculating the power of the pump, power of the motor, and overall system power. Now the system power will be represented by rho into G into Q into HD minus HS. The rho is the density of the fluid, depends on what type of fluid, whether it's a water or oil or furnace oil or sewage or effluent, different. Then what is the gravity acceleration due to gravity is almost constant, is going to be 9.81. And Q is the flow rate. At what flow rate it is designed at meter cube per second. It's a volumetric flow. It's not a mass flow. So it's a volumetric flow because it's a flow in a pipe or in a closed system. Therefore, it's a volumetric system. Then HD minus HS. HD is the delivery head and minus is the suction head. So if you know the HD minus HS, then automatically the total system can be easily calculated. Now the overall efficiency, so this is the hydraulic power delivered by the motor, pump. Now, if you know the input power with the help of a power quality analyzer, we can easily measure what is the input power. And you know the efficiency, then automatically we can calculate the output power. Output power of the motor will be the input for the pump. So we can get the input power of the pump. So we can directly calculate either the pump efficiency or the motor efficiency or combined efficiency. So that's a very important point. Always you can keep remember. Okay, so we need a motor efficiency separately, pump efficiency separately, or put together a common efficiency, the system efficiency for the entire pumping system. Now again, what are the equipment are used normally? We need to measure the flow. So measure the flow is going to be somewhat difficult, also cost-effective manner. Measuring the current is very simple, but measuring the flow is going to be not as simple. We need a separate meters. Sometimes it's electromagnetic meters, but nowadays the flow meters are ultrasonic flow meters. Ultrasonic flow meters are slightly costlier, but it is more accurate than compared to the electromagnetic meters. And head measurement, pressure can be indicated by the digital pressure meter, but where you have to put the pressure and how you are going to account it, that is whether we have to account the suction pressure, and similarly for the delivery pressure, then only we need to know the difference between that two. Then the input power can be measured with the help of a power quality analyzer or load manager. These three devices are normally used. This is a typical pumping system. We don't bother about that. Then we will come to the point of the curve. So any system we have the two important variables can be plotted with the help of a curve system or a curve system or motor curve or whatever, or even solar photovoltaic system will have a voltage current curve and power and voltage curve. Similar fashion, I have a pump performance curve. In the pump performance curve, I am representing the flow rate versus the head, okay, or pressure, flow versus pressure. Now you can see the flow rate. When the flow rate is going to be increased, then the pressure is going to be slightly decreased, and the efficiency of the pump will be maximum when the flow rate is going to be maximum at optimal pressure. Right now, this is the net positive suction head required. So this is different. How much amount of pressure is minimum required to pull the liquid from one place to another place? So that is very important. Otherwise, the pump will not pull your liquid. What you call this called bubbling effect. Bubble sound one day. So it will not. I mean, it try to pull, but the amount of pressure is not required to pull the liquid. Okay. So you have to operate your pump at nominal operating point so that you will get a good efficiency of the system. Okay. Now you can see there are system characteristics which will show you the static head and the variable head. Static head is the head designed by the system. Okay. Whereas the friction head depends on the piping system. I mean, what is the type of pipe, what is the size of the pipe, what is the material of the pipe. So those will be another important part. Okay. So we are not only closing to the actual head of the pipe pump, but we are also talking about the friction head, which is developed by the piping system and fitting system and bending. Okay, so that also taken into account. Okay, normally the static head is going to be constant because this is OEM original equipment manufacturer's design and based on your application. Whereas the friction head is going to be keep on varying, depends on the pipe fitting, where you are transferring the liquid. And is there any bend? How many bends? Is there any trap? Is there any uphills are available? So those things are considered into a picture. So therefore, your friction head is going to be keep on varying. That depends on your system. Okay. So these two are taken into account while you designing your piping system. Okay. So you can see this here. So easily it can go whenever if you bend it. Okay. So only thing is, when your size is going to be very bigger, then this is not enough. Rather, you can increase your size. So, but only thing is, friction loss increases with the capacity increases or the pipe length increases. That's also, but because increasing the pipe size is not only not a good solution, but keep remember that your friction losses also taken into account. Okay, something similar to providing a bigger conductor for small size. Of course, the conductor will not burn because current is very, very small. But what is the resistance? Resistance suffered by the cable is going to be higher. Because of that one, voltage drop is going to be higher. Energy loss is going to be very high. I squared R loss is also very high. So that's the important part. Now you have a system curve. This is your system curve. You can see this is the system curve, and this is your pump curve. So both are meeting at one particular point. That is the point where you have to operate. So in that area, if you operate, then automatically your flow is going to be better. Your pressure is also better. Suppose if you are operating here, then you can see the flow is lesser and your head is also lesser. Similarly, if you are operating here, then automatically flow is going to be very higher, but appreciable amount of head is not higher. So in either case, you will lose energy. Even though flow is higher or head is higher, then automatically you are losing energy because of generating the required head. You need to require a minimum amount of power. Energy. Okay. Now, what is the efficient pumping system operation? You need a proper system and the best solutions. Normally, the pump manufacturers will not tell you. I mean, they will give a common, but application is going to be different. So what application you are going to use it for your things. And similarly, whether the application is variable application or a fixed application, whether your water or a liquid flow is going to be always constant or keep on varying. So it depends on that. You may have a very proper sizing of the pump. Sometimes oversized pump or sometimes undersized pump will have a very big impact. For example, if you have an oversized pump, then the problem is going to be the throttle valve or the throttle valve control can be normally used to reduce the flow normally. When the water comes out of the pump is going to be very higher. Normally, what the people will do, they will give a throttle or a stopper to control the flow. So when you control the water will control. When you introduce a throttle, water will control. That is something similar to a tap. So if you open the tap fully, all the water will come out. If you open the tap partially, then only partial water will come out. But remember that when it is applicable to the pump, the water will draw the same power for the throttle output. But you are losing the output because you are throttled. You are stopping your water coming out of the system because you require lesser amount of water for the particular application. So on that case, if you have a variable flow, if you have a lesser value of liquid can be flowed, then automatically you can use, instead of throttling, you can use a VFD. So VFD is not a magic box always which will help you to conserve energy. Rather, definitely you need a variable system. Otherwise, the VFD will not work. If it is a constant, VFD will not work. We will not save your energy. That's why the name itself indicates it's a variable frequency drive. Why the frequency is varied? Because of my flow is varied. Because of my head is varied. Because of my output is varied. My parameter is varied. My temperature is varied. So based on my output variation, any parametric variation, my input can be varied by changing the speed of the motor. When the speed of the motor reduces, means automatically you know that power equal to directly proportional to cube of the speed. Okay, when you reduce 10% of the speed, 27% of the energy can be saved because of the affinity law. Okay, so that's the advantage. So what type of application will require throttling, impeller trimming, or what type of applications you require small impeller, or what type of application you require a variable speed drive or lower speed drive? That depends on your system. Okay. Now, best operating practices, you can properly maintain your impeller systems. Casting acoustic system, especially when you are operating with an ETP plant, bearing repairs, regularly inspected your seals, oil seal, mechanical system, wear and tear of the ring system, impeller, motor properly checked, alignment properly checked, and the throttling system properly checked. And your flow control, I already told you whether you can go for a throttle control system or start and stop, bypass valve. Sometimes you can bypass the flow to other systems, then impeller trimming. Then if you have multiple flows are available, then you can connect two pumps in parallel so that one pump can be operated for low pressure, or other one is low flow application, and another pump will be operated for high flow application. When you need both, then you can operate parallelly. Or the better way is to use VFD if you have a variable flows are available. Right? This is already discussed when you are operating an operating point, then automatically you are getting a good control of your system. So flow control, we have a very good control mechanisms are available now. Even water packs will have proper control mechanisms. Then you can have a bypass valve where when you start require, you can use the bypass valve to flow the system. Same thing when two pumps are operating, when three pumps are operating, how the flow can be varied. Same only thing is how the system is going to be changed. I told you this is the affinity law. Sorry. So when the speed is changed, means automatically your flow rate can be changed directly proportional. When the speed is changed twice, then automatically head pressure will be changed when the speed is changed. Okay, twice the speed. When the speed changes cube value, then automatically power can be directly proportional to the cube of the speed. Now you can see the 10% reduction in the speed will reduce 10% flow because it's a directly proportional. 19% head pressure reduction. When the pressure is reduced, it means automatically power drawn by the system is going to be reduced by cube. It's going to be 27% reduced. Then what are the energy saving opportunities? Already told you that you need to properly maintain your pumping system by reducing bend, valve, proper sizing of the piping, proper maintenance of the piping, resistance of the piping should be as minimum as possible. Sometimes you need a booster pump when the pump pressure is not sufficient. You can go for a booster pump for only a smaller application. Throttling can be reduced, rather you can go for an impeller tripping system. Bottom properly balancing to be conducted very properly so that the system will be working very finely. And this is the some examples of the system. Instead of a VFD, when you are putting the VFD, then automatically the pressure output can be reduced whenever the system requires. So this is another example. When the throttling is available, when you throttle with the help of a pipe throttling arrangement, only thing is desired power output. This is this one. Whereas if you implemented the VFD, then automatically your energy saving is going to be good than compared to any other systems. Now this is for normal application, and this is for the VFD application. So when you go for a VFD, then automatically it saves small amount of energy per your system. Now the overall efficiency of the pumping will be normally without a VFD is going to be around 30 to 40% normally. Sometimes it's 50. Maximum of energy efficient pumps will have a 50%. The only thing is when you introduce the VFD, that the efficiency can be improved from 40 to 50% to 72% because it's operating at a variable speed operation whenever if you require a variable speed. So pump efficiency or overall efficiency can be improved by this system. This is already discussed. So what are the best operating practices and energy efficiency measures? This is also already discussed. The right list of pumping is required. Flow rate must be properly managed. Filter suction point regularly cleaned. Sometimes the block will be always available, so that should be always avoided. Cavitation, formation of scales, that should be also regularly checked and cleaned. So for better operation, avoid throttling, avoid bypass, use VFD system. So many times we discussed. Now the last point is your air compressor. Okay. So this is also pump equal to pump, or this is also equal to fan, or this is also equal to your motor. Only thing is additional responsibilities. Now compressor air is a very important equipment for the industries. I think 90% of the industries are having compressors. Sometimes it may be a reciprocating compressor, sometimes you may have a screw compressors, or you have a scroll compressor or centrifugal compressor. Depends on the application is going to be different. Okay. The only thing is the amount of energy or amount of compressed air what you require and the amount of energy what you are going to give as an input, the overall efficiency is going to be only 10 to 30% is the main important problem for the compressor. Okay. So you are spending more amount of money to compress the air. Air is free, but compressor air is not free. So that is why always we will tell to the industry people that if any leakage in the compressor system, please arrest it and reduce your leakage below 5%. 5% is allowed. Even 10%, some industries 10% is going to be a maximum threshold value. But more than 10% reduction is not at all accepted. But I have a proof that some industries are even having 50% leakage. When we conduct the leakage test, we found that 30%, 40%, 50% leakages, visible leakages. That is completely that should be properly avoided. Okay. Now this is also something similar to the pump where it is work, but only thing is the way in which is going to be different. Taking the air from now taking the air, atmospheric pressure. Now delivering at the air at required pressure, at required flow. That's all. Only thing is only two parameters are changed. Required pressure and required flow. That's a difference. Okay. Now we have a three type of compressor: reciprocating, screw compressor, and centrifugal. Reciprocating is now it is replaced with the screw compressor. Even screw compressors are now fitted with a variable frequency drive. If in case you have a variable air is required. Now the air coming from the filter to this point and it is going to the screws and get compressed and output will be given like this. And similarly for the reciprocating compressor, taking the compressor air from the atmospheric and given to the chamber, and the chamber will compress the air and it will be given to the output. Yes. Okay. But some applications we are requiring a reciprocating compressor, some applications we require a screw compressor, even some applications we can have a reciprocating compressor Only thing is the way in which it is operating, the efficiency point of view is going to get different. And similarly, the initial cost is also okay. Now this is the Sankey diagram. Sankey diagram means what is the input you are giving and what is the output you are taking, and where the input goes in the system and in what way it goes. That's called as a Sankey diagram. Now you can see the electricity given by the given to the compressor. 85% goes to the as a heat. That's a problem. Only 15% is as the useful output. That's a problem. So because of compression, internally huge amount of heat can be produced. So you need to properly evacuate the heat, otherwise the system will be a problem. So normally discharge pressure, temperature, suction pressure, temperature, chamber temperature will be keep on monitoring in the screw compressor. So in screw compressor, if you see the display, it will have a set values of all the stages compressor temperature set values. If the value is going to be slightly higher, then automatically siren will be alarm will be alarmed, so that the compressor will stop immediately because of the higher temperature inside the system. Now these are the component of the entire air distribution system, not the compressor. Compressor is here, but output of the compressor air will go to different stages and finally it comes to the application tube. Now we have a compressor, and compressor will be given to the dryer. When we have a dryer means compressor air, we are taking the air from the atmosphere. Atmospheric air will have a moisture, but also compressor. When the moisture compressor means automatically it will turn into a water vapor. So that should not go inside the tube or inside the process. When it goes inside the process, then automatically rust will form in the equipment or in the system or in the final output. So that will affect the quality. So therefore, we need a filters and we need a dryer. So dryer will take the dryer will take the moisture content of the air, and pure air will be given, and it will be stored in a tank. Okay, now the tank will be given to the piping system. Normally, the piping system will be this one, ring type. It is completely ring, or sometimes it is a radial main. Radial main means it start here, end here. Okay, it will not come back. That's called as a radial. So ring main system is going to be a disadvantage one, rather radial system is going to be the better one because it has a uniform flow and uniform pressure inside the tube. Okay, so therefore, if you connect one machine here, both the machines, even though it is apart from some other place, but they will get the same pressure. When the pressure is going to be same, then operating of the equipment will be good. Something similar to the voltage. When the voltage is going to be proper for all the equipment, then automatically equipment will function very properly. I told you 99% of the electrical equipment available is the voltage sensitive equipment. Electrical equipment. I'm talking about electrical equipment. When you adjust the voltage, then the output of the parameter will also adjust. Take some example of a fan. If you reduce the voltage, the speed of the fan will reduce. When you increase the voltage, then the speed of the fan will be also increased. Similar fashion, pressure of a piping system is also important. If you maintain a proper pressure throughout the entire region, if you maintain a constant pressure, then automatically there won't be any problem for the equipment. But remember, as an electrical system, you have a voltage drop. Similar to that, in compressor air system, you have a pressure drop. Because sometimes the pressure here is going to be 7 bar. Sometimes the end may be 6.9 bar or 6.8 bar. Because of the internal flow, automatically the pressure drop is always available. You measure the voltage at your load end, sorry, at your supply point. It is going to be 230. But if you measure the voltage at the equipment end, it may not be 230. It should be 290, 228 or 227 because of the drop. Okay. Now the same case is going to be applicable. So your pressure drop is inevitable, but it should be as low as possible. Okay. So you have to maintain almost same pressure. What we call as a voltage regulation. The voltage regulation means you can get the same voltage at the load point and similarly the supply point. Then the regulation is going to be 100%, which is not practically possible, but we have an achievable target of 95 to 98% voltage regulation. Similar fashion, here also you will get the 95 to 98% pressure regulation, so that you will have a good equipment system to be operated. Then you have then filters, lubricators, all the equipments are. routinely monitoring parameter, how much hour it is running, what is the load hour, what is the unload hour, what is the current, what is the load, unload pressure, load pressure. Okay, but what is the meaning of load and unload means? During the load, it will take the power, it will take the air and start compressing. When the pressure reaches the set point, then automatically no need for operating the motor. Now the motor start deloading. That's called unloading and unloading effect. That means the air intake is going to be completely zero, but the motor is running. Motor is running, but the air intake is going to be completely zero. So motor is running ideal. That's called as an unloading condition. Because air already available in the system, already available in the process. We do not require air. Already I compressed the air. When the air requirement comes again, then automatically again it starts loading. So this is called loading and unloading of the compressor. So normally the loading percentage should be 80 and the unloading percentage should be 20 for a better system. Even higher is also welcome. But lower the value, that means 60% load and 40% unload, means you may have higher leakage, or you may have an insufficient compression, the size of the compressor, or many reasons are there. So better you can have a good load and unload ratio. Normally the unload region is called as an unproductive region. Motor is running, but it not doing any productive activity. So therefore, unloading should be as minimum as possible. Okay. Now similarly, you have to test the air leakage in the piping system and at regular interval, either weekly once, monthly once, monthly twice, and you have to reduce the system. And also you can have a filter cleaning, input filter cleaning, output filter cleaning, dryer filter cleaning, then intake filter cleaning. All the cleaning should be properly taken. Now the best operating practices is here. You have to monitor the discharge pressure, monitor the loading, unloading. I told you, unloading our oil temperature inside the oil, cooling oil temperature should be monitored. The temperature is very higher. Separating oil will not commit the heat, then automatically the compressor is there. Now the current loading, during the loading operation. And similarly, the air compressor loading percentage, start and stop, and what is the again when the air is not required, either you can stop it or you can throttling it, or you can use compressor, or you can use a VFD. VFD system. See, so unloading percentage is going to be very higher, and you can have a higher fluctuation. Continuously, you can have a fluctuation that can be reduced with the help of a VFD. Is reduced. Okay, loading and unloading. That already I told you. See, this is loading, and this is unloading, and this should be higher time, but the power consumption should be low. So these are all the points to be always taken into account. You can keep your air filters regularly. You can wash the air filters. Keep your intake air should be very cool. So for every 4-degree decrease in pressure, then the power consumption will be reduced by 1% or vice versa. Just the opposite. Regularly clean the filters and take to be very cool. Keep compressor in a good condition, and regularly clean your dryer, moisture separator, and all those things. Okay. Now you can see 4% of increase in the air temperature, input air temperature will increase 1% of the air, so that will also harmful for the system. Then you can properly maintain the entire compressor piping system, compressor distribution system, and throughout the entire, all the components should be properly checked and regularly monitored. Then what are the energy efficiency opportunities are available in the compressor? You can go for reducing the leakage. You can go for reduction of the system and operating pressure, optimal pressure to be properly selected. Then you can go for an installation of VFD. So that also, when the flow is different, then you can install VFD. Sometimes you can also get the heat generated inside, can be used for heat recovery system, can be used for other applications. This is the formula for calculating the leakage. So system leakage can be calculated by T divided by T plus T, where capital T is the load time and small t is the total time. It's unload time. So load time divided by total time multiplied by 100 is the system leakage. This should be as low as possible. I told you 5% or 10% is applicable. More than that, it's not applicable. It's not acceptable. Okay. Now multiply by how much amount of air it delivered. So that is the quantity of the leakage. Multiply by what is the flow rate. Multiply by that will give the system leakage. This is the simple example. You can see an 18 kilowatt, 115 CFM compressor, cubic feet per meter. Compressor operating at load time equal to 29.78 seconds and load time equal to 14.5 seconds. So load time divided by total time, the leakage percentage is 67%. See, this is 67%, very, very huge. Multiply by the standard design of the compressor, 150 CFM. That means out of 150 CFM, 77.37 cubic feet of air is going into leakage. Going in a leakage. So you are taking the air, compressing it, and 67% of the air will be throwing out, not productive, not used. So it is approximately equal to 77 cubic feet per minute over minute. Every minute, your compressor air will be wasted nearly 77 cubic feet volume. Okay. Now you have to quantify with the help of this system. You can use a VFD system like this, a case study, and you can see this is the heat recovery. This is not applicable for the small compressor. Other water-cooled compressor, this is applicable. I saw one water-cooled compressor, 800 CFM in Chennai, a paid company. There they are using 800 CFM compressor of huge size, 3 numbers. They are using a water-cooled compressor. So that water can be used, it's going inside to take the heat from the compressor. That hot water can be used for some other process application like showering, spacing, or boiler application, or whatever maybe. So that can be easily used. Then these are all the points always to you can use the proper pressure. Then it should be a ring main system. Then avoid leakage. Pipe diameter should be lower pipe diameter should be avoided. Pressure drop should be minimized, and these parameters are already discussed so many times. Best operating practices: good pressure, low pressure, and high pressure. You can operate separate compressors. Moisture should be properly removed with the help of a dryers. Keep watch on the dryer. Then unloading power should be as small as possible. Check the leakages regularly, and you can see the inappropriate use of compressor. So sometimes you require a very small flow, so that can be taken by the blower, not the compressor. So instead of having a blower, you are using compressors. So therefore, you can use what type of whether you need a compressor or blower. Okay. Sometimes. So ventilation, you require fan and blower, not compressor, and similarly for liquid agitation. Transporting material at low pressure, blower is enough, not compressor. Automizing, again, you need a blower. Similarly, for vacuum generator, you need a pump, not the compressor. This is the best operating side. We talked about that leakage test, implementation of the VFD, check the pressure. That's all about my side, and I will show you one out of slides, which is taken from our presentation. 1 minute. Within 10 minutes, I have to finish it up. Because we have an assessment today on today's topic. I will show you some case studies where we conducted some audit and measurements, some good photographs. I think you can be able to see my screen. Snega madam, is it visible?
Yes, sir. You're visible. Your screen is visible.
Compressor air and compressor distribution system. First of all, this point I told you, the specific power consumption, specific ratio that will decide whether it's a compressor, blower, or fan. So if your specific ratio is 1.11, input power divided output power, then it is going to be fan. If it is between 1.11 to 1.2 is blower, more than 1.2 is a compressor, or the pressure what you are going to maintain. Right? So these are all the component. Always we will look into a picture that already we discussed. See, I can see some of the compressors which are open. All the gates are open because it's very hot. The entire area is very hot. So 4 degrees of temperature rise will increase 1% of energy consumption. Okay, so you need to invite cool air, not the hot air. And hot air generated by the air, by the compressor, should be removed with the help of this ducting arrangement. You can see, this is the one company will provide a very good ducting arrangement on the top of the compressor, duct out the heat generated by the compressor. You can see this is another case study where 3 compressors are available in the same roof. Okay. So 2 compressors are screw compressor, one is a reciprocating compressor. This is not running continuously, but rather these 2 running oftenly. Now this compressor will have a duct to evacuate the heat, but this compressor does not have the duct to evacuate the heat. Okay, now what the problem is, this compressor is adjusted to this one. So what the problem is, the heat generated by the compressor will be taken as an input, because this is the air input point of this compressor. So you can see that the thermography image, the ambient temperature is going to be only 28 to 30 degrees, whereas at the filter side, because of the hot air generated by the other compressor, the hot air is going to be 55 to 60 degrees. So therefore, we recommend to have a separate ducting for this one. Similarly, you can go for regular cleaning of your filters, and you may have go for this type of few filters that can be retrofitted to clean the system. And based on your compressor load, whether you can have a higher load and lower load, you can decide your pressure. Normally, the motor or normally the system which requires compressed air, the nameplate itself tells that how much pressure is required to operate the pneumatic application of the machine. So based on that, you have to set the pressure. So see, very important point. This machine, the CNC machine, require only 5.5 bar. So you may give 5.8 or 5.5, sorry, 5.6 or 5.7 or 5.8 or even 6, because the operating pressure is required is only 5.5. Rather, if you are giving an 8 bar pressure, it requires only 5.5. Why you are giving 8 bar pressure? Reduction of 1 bar pressure of the compressor will reduce 8% of your power consumption. Okay, so optimally operate your pressure, optimally set your pressure. Pressure setting is purely depends on the machine requirement, where you are giving the compressor air and what is the requirement of the machine. So based on that, you have to decide. And you can go for an BFD if required. You can see this is the loading pattern, unloading pattern. Loading is 47%, unloading is 53%. So energy consumption is 30.5. Rather, we are installing the VFD drive. Now the loading pattern is 90% and the unloading pattern is 10%. So earlier it is a 30.5 unit per hour. Now it is going to be 19.2. So 40% saving by implementing this one. So, but only thing is you need a proper auditing whether the loading percentage is going to be lower and the higher unloading is going to be higher. Where you are placing the air receiver tank, it should be in the roofing. And there is no pressure gauge, and similarly, there is no working gauge, calibrated, no error. I mean, most of the cages are not properly working. Similarly, drain valve, always available in drain valve to evacuate the, whenever if you have an air receiver, that air receiver, the bottom water drops will be available. That should be properly drained out with the help of a drain valve. So sometimes the drain valve will be cycle based, or sometimes it could be timer based. Timer based means every 8 seconds, the 8 minutes or 8 seconds, the water will be let out. But now it is going to be replaced by a level sensing water. And similarly, a manual drain valve. If you open the manual drain valve, apart from the water, air also come out. So this is again, it's not good practice, because we need only water to be come out. Rather, air should be in the receiver itself. Then you can plan for a ring main system like this to maintain the proper pressure. And you can regularly conduct the loading and unloading test with the help of a testing schedule like this and find the average. And do this test at regular interval. Check the descent pressure and descent flow, and find the leakage percentage and what is the actual and what is the design, and what is the corrective action taken place after the leakage test. And after the corrective action, again you can do the same leakage test and whether the value will be reduced or not. Then automatically you can go for another type of solutions. You can see some of the pictures where air handling system will have leakages, holes, nozzles, properly using nozzles, air put in a nut. Heat recovery. Output heat can be used, taken with the help of a duct system that can be used for preheating the aluminium bar. So waste heat recovery. This is a screw compressor, but screw compressor fitted with the VFD drive. So whenever if you have a VFD drive, then this type of spikes should not be available. But this system will have a spikes, not in all the cycles. Some cycles we have a spikes. Then we inspect what is the problem. We found that there is a loose connection in the system, and that can be found out with the help of an and this is the reciprocity compressor. Reciprocity compressor does not have any VFD, normally not available. 1 hour, for complete 1 hour, it on 1, 2, 3, 4, 5, 6, 7, 8 times it on. So it is a direct online, DOL starter. It's a direct online. Reciprocating compressors are 99% direct online starters, directly online. And keep remember that any directly online starter, any DOL based starting of the motor for 1 hour, the start and stop should be only 4 times for 1 hour. If it is more than 1 hour, then the motor life will be deteriorating. Now you can see this motor, the compressor motor, operating 8 times. Very oftenly it will break down because of failure of the insulation, because of failure of the winding system. The noise level in the compressor room to be properly checked. It should be as full as possible. It should be closed. And the safety certificate for the air receiver also matters. Sometimes the air receiver bust, then automatically huge amount of losses in terms of equipment, in terms of manpower. So properly you need a safety certificate. So what is the driving system? The motor and the compressor. What is the driving system? Are you using a direct driven or belt driven? You can see the 2 compressors. One is belt driven, CTSD belt driven, CTSD direct driven. Of same capacity, same company, same capacity. One is belt driven, another one is a direct driven. Belt driven will offer 2% losses in the belt. Rather, direct driven will have a 2% lesser losses in the system because there is no belt. Only thing is initial cost is going to be slightly higher. So that also you can take an account when you buy the compressor. Then you can have a good recording, a good failure history about the compressor, repeated failure, non-repeated failure, mean time between failures. You can have a good stock on the compressor systems. Then sometimes you can go for an air outsourcing. This is another important area where the people are coming to picture. Your compressor, your plant, your input cost, but it is completely maintained, operated by third party. So maintenance will be taken care of by the third party. They will give a uninterrupted, regulated air to your machine, and they will operate the compressor, and they will get the money for 1 CFM. So this is fixed. This is called air outsourcing. This is now available for even boiler outsourcing, steam outsourcing. For 1 kg of output of the steam, this much amount you have to pay for this person. They will take care about the operator, take care about the maintenance, take care about the fuel, everything. Only thing is you need to give the space, and you need to give your facility, boiler, and you need to give your inputs. That's all. Operation will be taken care by these people, and they will give a supply, a very good quality of, and they will take care about the leakages and all those things. They will reduce the leakage. No need to have a separate team for the maintenance. They will take care about this one. So this is called outsourcing activity for HVAC system, air, and the boiler. That's all about my side. I think I closed almost by 4 o'clock. 3:57. A small announcement here is you have an assessment now. Assessment will contain 20 questions. It will be circulated now. I think Ananya madam or Sneha madam will the Google link, Google form. So you can log into the Google form and you can start answering the questions. It's a multiple choice question, MCQ type, where you can have 4 answers are available. Appropriate answer can be taken. Okay, there is no negative marking, and the time allotted for this is only 20 minutes because only 20 questions are there. Only 20 questions. So all the 20 questions are asked, or some questions may be yesterday class. Some questions may be by small imagination. Of course, I discussed it in the class, but I didn't show in the picture, or I didn't mention. I didn't have any PPT on that. But I mentioned. Definitely, I mentioned. Okay. So keep remember that if you have a notes, or if you have if you have an idea to answer, you can answer these questions. Okay. Now can we start, madam?
Sir?
Madam, can we start the assessment?
Yes, sir. Sure, sir. So I'll just make an announcement. So I've shared the links for assessment and feedback here. Let's start with the assessments and go ahead for 20 minutes straight. So after 20 minutes, the responses will close. So please make sure you do the assessment sheets right now, starting right now within 20 minutes and submit it. After that, we can do the feedback forms. So yes, sir, we can go ahead.
Okay, you can share the link, madam.
Yes, sir, it's in the chat box. I've shared it in the chat
Okay.
box, sir.
Okay. Now it is available in the chat box. You can open your assessment form. Start answering. Prabha madam, it is available. It's available. You can see the top assessment form, day 2.
Maybe I think she just entered the entered the chat room. I'll share it again.
Please.
So just to make it easier, it's 1 minute to 4 o'clock right now. Sneha has shared the day to, yeah, Sneha, just share the assessment also. Can you share the feedback? Yeah. So
Yes, ma'am.
The assessment starts. So yeah, it's 4 o'clock now. At 4:20, sharp 4:20, we'll be closing the responses. So you will not be able to submit your responses. Please make sure all responses are submitted, because after that we won't be taking in any more. And we'll be giving you a warning. Sneha will be giving you a 5-minute warning and then a 2-minute warning, just so that we are all on track and we keep time.
Good, madam. All the best for the participants. Please try to answer all the questions.
Yeah, and please, after 4, don't log out of the Zoom meeting, because after 20 minutes we'll come back to the same platform. We'll still have a few things to discuss. So after at 4:20, just come back to the Zoom meeting room. Don't log out.
Hello. So out of the 20 minutes, 15 minutes have passed. We have 5 more minutes to go. After that, the feedback, the assessment forms responses will close.